Yes, hello my dear friends, welcome all of you to the ISRO previous year question solution analysis. My dear friends, in this session we will discuss the ISRO previous year question that has been asked and we will share their detailed solution, and at the end of the session you could be able to analyze that yes, what type of question is going to be asked in the ISRO. But before starting the session I want to tell you that you have to be prepared very well for the ISRO, then only you could be able to crack that exam. Because you know ISRO that is post for the scientist, so ISRO want that type of student who can think like a scientist. So if you solve the question later on, as you move forward you will see the different questions, you will find that they will make you like a think like a scientist. If you are not able to thinking, then really my dear friends, it will be little bit tough to crack that exam. So you have to be think like a scientist and you have to develop that potential. If you don't have, you have a time, read the concept and try to think different possibilities that can be framed on that concept, then you will easily crack that exams. Let's start the discussion and see which type of question is going to be asked. Lot of question I have to discuss in this session my dear friends. And one more thing I want to tell you, that session will be little bit longer session, because you know ISRO question are there, 85 question are, so it will be take longer time. You have to be just keep a patience and see the solution all the question and see how you have to be think on the questions, right? So let's start with the first question. Yeah, initial few questions are easy, but as you move forward you will get difficult questions. So that question is easy my dear friends, anyone can do that, no problem I think. So that is the first question on your screen. A beam is subjected to uniform load WC per unit length, right? WC per unit length, and MA, VA and VB are the reaction as shown in the figure. The expression for shear force and bending moment is given by, and that option you have my dear friends. So that is the question of the strength of material, and simply from the SFD and BMD my dear friends. So simply what you can do here, simple take one section there, right? Take one section, suppose that take a section x distance from that one, this is the x. Now I will ask what will be shear force about xx, that is our section xx. Let's assume xx section is there. So what will be shear force my dear friends? What will be shear force? We can say there is a one force VA is acting, so it will be VA in the upward direction. You are moving left to right, upward is taken positive, right? In the SFD BMD if you are moving left to right, then upward shear force is taken as positive, downward is negative. That is the concept, simple. So and how much total force? Sir, this is WC Newton per meter, no sir. So in the x meter how much force is acting? Sir, it will be WC into x, right? So it will, but in the downward direction, so it will be minus WC into x. So shear force will be VA minus WC into x, that is the shear force. Simply we can go through the option, we can say either it will be answer B or D. A and C can't be option. Okay, now think about the moment about x-axis. What will be moment about x-axis section? Simply we can say sir, this is VA at a distance x, they will try to rotate in which direction? Clockwise is taken positive my dear friends. So we can say sir VA into x. Now there is a one couple, MA is acting, this is also in the clockwise, left to right clockwise is always positive, left to right clockwise is positive, left to right upward force in the shear force diagram is taken as positive. Okay, so VAX. Okay, and MA, this is here you can see one couple concentrated movement is there, MA, so it will be positive, so simply MA. But sir, what is that force? W Newton per meter, WC in the x Newton how much force will be? How much force? So we can say sir WC into x. But what is their line of action? Center pe na sir, it will be at the center. So WC into x, and that distance will be what my difference x by 2. But they will try to rotate in clockwise, anti-clockwise. That force will try to rotate in the anti-clockwise direction. Left to right if you are moving, it will be negative. So simply we can say sir it will be WC into x by 2. And by solving that sir, simply I can say moment about x-axis is coming out to be MA minus of VA x minus of WC x square upon 2, and shear force you have get. So according to the option my dear friends, Bombay cannot be answer. The correct answer is what? D for Delhi is the right answer, and we will get the answer. So it was a very basic question. If you know the SFD BMD you could be able to solve. There is nothing like you have to be think like a scientist, but yes, in the upcoming question you have to be think like that. I am coming on that next question. So my dear friend, that is the next question has been taken from the machine design. That question has been taken from the machine design, but yes, little bit good question it is also. See my dear friends, and just use the concept, and you can simply say the aptitude, like you have to just think like aptitude, you could be able to solve that question very easy. See the question: a weld with a triangle cross section as shown below is to be the produced on a steel workpiece by shielded metal arc welding. Here which type of arc welding is? Shielded metal arc welding is going to be performed. Operation using a steel electrode. Okay, if 24 volt power supply is used and the welding speed is given 12 mm per second. Okay, what is the current needed? Assume the efficiency is 80% and the specific energy melt steel is 8 joule per mm3. So what is the current needed? What question you have to be calculate? In this question, sir, I need to calculate the I, and yes, I need to calculate the I. How I can calculate? Now start thinking how I can calculate. Sir, in the question, sir, here we can see voltage is given, na sir? हाँ sir, voltage is given. So simply I can say, sir, P equal to V into I. Yes sir, I can say. Sir, anyhow, in the question voltage is known, I have to be calculate I. If anyhow I am able to calculate the power, then I will get the I. Yes sir, I can. But how I can calculate the power, sir? How I can calculate the power? So my dear friend, just think. See there, that is the triangle now, but joint section it is. So what will be area of that one, my dear friends? What will be area? So simply we can say, sir, half base into height. So what will be their area? This area. Simply by solving that we can say area will be area of that one half B into H. So simply we can say total area 1 by 2 into B is what, my dear friend? That is given 5 and that is 5. It is coming out to be how much? 12.5. You can say mm square, right? Okay. Now coming to the next concept, next thing, area you have get. Sir, now tell me what will be the volume of weld meter deposited per second? That is the area, and see that is the area, fine, that is, and you can see here that welding speed is given. What is welding speed? My dear friends, in the question welding speed is given how much? 12 mm per second. Means in 1 second they are going to weld in the 12 mm. 12 mm distance is going to be weld in 1 second, and the area is what? 12.5 mm square, right? Now my dear friends, if I will ask what will be the volume of metal deposited per second? Volume of metal deposited per second. Metal deposited per second. Tell me what will be, my dear friends? So we can say, sir, area into velocity, right? Like a discharge. You can say the discharge. So what will be area into velocity? So area into velocity, weld velocity. So it is coming out to be how much, my dear friends? Sir, 12.5 into 12. It is coming out to be mm cube per second, right? This is mm square, and this is mm per second. It is coming out to be mm cube per second. So this is the volume flow rate, sir. I get the volume flow rate. Now see, my dear friends, we can say that is the volume. Means in 1 second how much metal is going to be melted out. In 1 second we can say, sir, 12.5 into 12. By solving that, how much it is coming out to be, my dear friends? It is coming out to be 150 mm cube per second, right? Okay, mm cube per second. That means in 1 second that much amount of metal is going to be melted out. That much amount of metal is required. How much? 150 mm cube. But sir, see there, how much energy is required? Here we can say the specific energy to melt, means to melt 1 mm cube. To melt 1 mm cube you need how much energy? Sir, 8 joule. Okay, to melt 1 mm cube you need 8 joule of energy, my dear friends. So tell me, to melt 150 mm cube, how much energy is required? Yes sir, that is the simple, you can say, mathematics, aptitude, nothing else. So we can say, yes sir, here specific is given, my dear friends. So okay, I can, some student think, sir, I don't know what is the specific energy. In the option we can say the energy required to melt per unit volume. Energy required to melt per unit volume is known as a specific energy. So this is given 8 joule per mm cube. And in 1 second how much is going to be melted out? So we can say 150. So I can ask energy required per second, or this is called power. Energy required per second. This is also known as what, my dear friends? This is also known as power. Sir, it is given by, simply I can say 150, and specific it is given how much? 8. It is coming out to be 150 to 8. How much it is coming out to be? Sir, 1200 joule per second. That means 1200 watt is coming out to be. Yes sir. Now come to the, again see the question. Sir, in the question it is mentioned that Assume the efficiency is 80%. Means sir, if you talk about shielded metal arc welding, I am coming to you. See my dear friends, this is the one of the object, and that is your electrode, and your electrode is connected with the some terminal like that, and this is like that. So actually energy required is how much? 1200 watt is energy is required. That is coming from that one. But the efficiency is given here how much percent? 80%. Means whatever energy is coming, there only 80% is going to utilize for the heating purpose. Rest 20% what is happening my dear friends? Whenever the coming it through the arc could be possible going to in the form of radiation, going in the form of convection or radiation. So only 80% is reaching there. But you required how much? 1200 watt required. So how much you have to be supply? How much you have to be supply? Obviously more than 1200, no, sir. So what will be efficiency my dear friends? Simply I will ask what will be efficiency. So we can say sir, efficiency will be useful power upon electric power. Useful power upon, we can say, supply power, or whatever is electric power, whatever you can say, electric power. So actually useful power that you have to be get is coming out to be how much my dear friends? It is simply we can say, sir, if need the electric power, what will be electric power? Electric power or supply power, whatever. Simply we can say useful power 1200, and upon efficiency is given 0.8. By solving that, how much it is coming out to be my dear friends? 1500 watt. Means you have to be supply the energy how much my dear friends? 1500 watt. So can you get the power? Yes sir, I have get the power sir. Yes sir, I have got the power. Power is how much sir? Electric power is coming out to be 1500. Can you know V is equal to I, V and I, power equal to V into I. So can you calculate I? Yes sir, I will calculate. By solving that, we will get velocity, voltage is given 24 volt, and by solving that I get you will get 62.5, and approximate we can come with the answer. The correct answer will be the approximate. If you are going to do, we will get the 75 ampere. So current will be 75 ampere. By that we will get I. So my dear friends, ampere. So you have to be think like that. That was just a aptitude question. I don't think if it much more anything is required there. Just you have to be think. You need what? Electricity or current. How I can get the current? In the question voltage is given. So if anyhow I calculate the power, I can get the I, because voltage is known. So how I can get the power? Just area, velocity per second, how much metal is going to be melted out, how much it is going to be deposited out, and accordingly in the question here that data is given. That is that much of energy required to melt 1 mmQ of volume of metal, and accordingly we can proceed. Right? I don't think, yeah, little bit calculation, but overall question is moderate. Now my dear friend, that question, next question is that the specific stiffness of material is defined as the ratio of mass to Young's modulus, density to Young's modulus, Young's modulus to density, Young's modulus to mass. A specific stiffness my dear friends, right? Okay, what do you mean by the stiffness? Anybody? What do you mean by the stiffness? In the spring you might have a study, or I will teach you in the class. Stiffness is basically, this is the spring, let's assume, and their stiffness is K. So what is K? K is load required unit deflection. What is stiffness? Load required to unit deflection. Suppose if deflection is 1, so K is equal to W, and you are going to apply the W, right? So energy required to unit deflection is known as stiffness. Even a spring has a stiffness, even you have a stiffness something, even that marker have some stiffness, even this marker have some stiffness, everybody have some stiffness. That different things, someone have less, someone have higher, that different things, but yes, everybody have a stiffness. So sir, in the, okay, getting sir, what is a stiffness? A stiffness is basically energy required to make a unit deflection, that is called a stiffness. But sir, in the question is that given a specific stiffness. So a specific stiffness is always given by my dear friends E upon what? Rho. E is what? Young's modulus of elasticity. Rho is what my dear friends? Density. So we can say sir, C for Chennai is the right answer. Young's modulus to the density you are getting. This is called a specific stiffness, right? Even my dear friends, just to, you can correlate one thing. Why it is called a stiffness? You know, suppose that is one of the object, and you are going to apply the load P. and this is a prismatic bar, load is axial, so what will be change in length? We can say sir PL upon A, no sir, PL upon, this is change in length, PL upon A. Suppose if everything is constant, PL, A all are constant, so can I say del L is 1 upon E proportional to Young's modulus? Yes. So what if Young's modulus is higher, delta L will be less, and what is delta L? Change in length. So it resists the change in length, the stiffness resists the change in length, and if you are going to divide it by rho, then you are getting what, my dear friends? Simply a specific stiffness. Okay, coming to the next question, that is the next question, which of the bearing given below is not suitable for axial thrust rod? Axial thrust rod, which one is not suitable? And you have an option: deep groove ball bearing, angular contact ball bearing, single rod tapered bearing, and option D is what, my dear friends? Simply we can see, sir, option D is given here, a straight cylinder, that thing, right? So what you have to do, my dear friends? See, if you talk about deep groove ball bearing, so it can handle radial as well as axial load, but axial capacity is what? Limited. A straight cylindrical roller bearing is designed to handle, see this, a straight cylindrical roller bearing is going to design to take a what? Axial thrust rod. Axial thrust rod. What about deep groove ball bearing? My dear friends, they can take both axial as well as radial. Axial as well as radial load, both they can take. But if you talk about deep groove ball bearing, axial capacity is limited. This capacity is what? Limited. This capacity is what? Limited. If you talk about angular contact bearing, they can also take the axial as well as radial, but generally tapered roller bearing is going to be used here. So you have to be just keep in mind that a straight cylindrical roller bearing is going to be used. Now coming to the next question, that was theoretical question, easy question it was. That is the good question, my dear friends. That is the good question, and we can solve that question. That question has been taken from strength of material, and you can do that. What the question is that a solid bar 50 mm diameter and 200 mm long consists of a steel and aluminum part joined together. A steel and aluminum part joined together. When axial force P is applied to the system, a strain gauge fitted to the aluminum indicate an axial strain of 800 micrometer per meter. Okay, what is the corresponding axial strain on the steel, assuming E of steel is given 200 gigapascal or E of aluminum of given, Young's modulus of aluminum is given 700 gigapascal. So how you can solve that? Just think, my dear friends. Now think like a scientist. Okay, yeah, how I can think, sir? Nothing, just draw the diagram what is given in the question. Don't be hesitant, don't be hurry, don't lose your patience ki I can't solve. Like that question you will find. So how many questions you can left? So solve that question. Sir, a solid bar, right? So sir, this is a solid bar I have, right sir? This is the solid bar I have, and sir, this solid bar is made by aluminum plus of steel. Okay, this solid bar is made by aluminum as well as steel. Fine, that has been made by the alloy of aluminum and steel. In the question, sir, length is given, sir. This length is given in the question. How much, sir? This is given 2000 mm, means we can say the 2 meter. And sir, bar diameter is also known, sir. This diameter is also known, and this is how much, sir? 50 mm. Okay, sir. Fine. What is the okay? One force here, axial force P is applied. When an axial force P is applied to the system, okay, there is one strain gauge is fitted. One strain gauge is fitted. A strain gauge of the aluminum. A strain gauge of aluminum is fitted, and they are going to be read how much axial strain is going to be read 800 micrometer per meter. So what is the corresponding axial strain in the steel? What is the corresponding axial strain in the steel? You have to be calculate. Means, sir, in this question I have to be calculate the strain developed in the steel. Fine, that is the question. Now the thing is that, sir, how I can proceed in the question? the data that I have given. According to that, how I can proceed? My dear friends, first of all, you have to calculate the stress. Calculate the stress. Once you get the stress, my dear friends, stress will be same. This is same material, so stress will be same for both aluminum as well as steel. Once I get the stress, that stress will be same for both the object, and from that stress I can calculate the strain, because you know, my dear friends, you can know now, sir, stress is proportional to strain within elastic limit according to the Hooke's law. So sir, stress is equal to this epsilon, right? So sir, in the question, if I talk about stress in the steel, in the aluminum, if I have to be stress in the aluminum, if I have to be calculate, so it will be E of aluminum plus this of aluminum, not plus, this will be multiply. So in the question, E of aluminum is known, sir. E of aluminum is known. How much, sir? 70 gigapascal is known, sir. So can I say, sir, sigma stress developed in that one 70 giga, na sir? So 70 10 to the power 9 I am going to write. Aluminum is given how much? 800 micrometer. 800 micro means 10 to the power minus 6. Okay. From that we will get the stress value. How much it is coming out to be, my dear friends? If you are going to be solved, let me check. By solving that, this value is coming out to be 56 megapascal. By solving that, you will get the value is coming out to be 56 megapascal. Okay. So sir, and sir, you know, since both are same, so stress whatever developed in the aluminum, it will be equal to same stress developed in the steel. It will be same, sir. Okay, that means the question becomes easy. So I can say, sir, stress developed in the steel is equal to 56 megapascal will be equal to E of steel into epsilon of steel. I have to be calculate epsilon of steel, right? I have to be calculate epsilon of the steel, the strain of the steel. It will be 56 into 10 to the power 6 upon E of steel is given how much? E of steel is given how much, my dear friends? 200 gigapascal. Fine. So just put the value 200 into 10 to the power 9. By solving this, I think this value is coming out to be, just solve that, and by solving that, this is coming out to be 280 micrometer per meter. 280 micrometer per meter. So it was an easy question. You have to be just brief on your concept. Don't be feared just by reading the question. Sometimes it's happened, my dear friends, a student just feared by reading the question. You have to be improved on that. Just read the question, believe on the concept that you have read, and try to apply that concept rather than fear how I can do that, I don't know. Just think and then proceed. That's why I used to say in the BARC, not in the BARC, in the ISRO exam, you have to be think like a scientist. You have to be positive mindset. When you are going to solve the question, your mindset should be positive. You know, that is a one play major role during the solving the question. Once you read the question and you have not a positive attitude, you don't have positive mindset, you will leave the questions. So attack on the question with positive mindset and try to do. I cannot say that will become in only one day you can do like that. Yes, but continuously you have to be improving yourself, and at the last you will find yes, you are thinking like a scientist and you will get selected there. Right? Okay, my dear friends. So now coming to the next question without wasting your time. So see that next question. What the next question is there? Question are there. Two flanges are connected by a single bolt of nominal diameter 10 mm is preload to a torque of how much? 30 Newton meter. Okay. An external tensile load 10,000 Newton is applied to the joint. The torque coefficient is 0.15 and joint stiffness is given. The maximum tension you have to be calculated. Just give 1 second. Okay. So my dear friends, how we can do? So two flanges are connected by single bolt. You have a two flanges. So it is connected by a single bolt of nominal diameter. So dia of bolt is given here. Dia of bolt. This is given 10 mm, right? And preloaded to a torque. Preloaded torque is given 30 Newton meter. Now see, an external tensile load 10,000 Newton is applied to the joint. Whatever joint is there, so there how much Newton? 10,000 Newton force is going to be applied to the joint. And the question torque coefficient is also given, my dear friends. torque coefficient, simply we can say KT, torque coefficient, KT is given, the value is given how much, simply we can say, okay, and stiffness constant is also given. The maximum tension in the bolt you have to be calculate. So my dear friends, maximum tension you have to be calculate in the bolt. So maximum tension is basically because of two force, Fi and Fe. Now first see, P, or we can say preload torque is always given by, preload torque is given by, preload torque is always given by, my dear friends, K2 Fi into D, KT Fi into D. What is KT here? What is the KT? Anybody can tell me? KT is torque coefficient. Now I am going to write KT is torque coefficient. Fi is initial preload force, initial preload force, and D we can say the nominal dia. From there, can you calculate Fi? In the question, preload torque is known, so T upon KT into D. In the question, everything is known. Torque is given how much? 30. KT is given 0.15. and D is given 0.01. By solving that, we will getting Fi. The Fi is coming out to be, this is called what? Fi is called initial preload. It is coming out to be, I think, 20,000 Newton. Yes sir. So is this our answer? No, my dear friends. There is a load is also acting. Load is also acting on the bolt, and this load is how much Newton? 10,000 Newton is also there. If it note would be there, then I will go with the option B. If there is no like that, then I can go with the option B. But okay, but in this question, load is also there. So my dear friends, what I have to do now? Now addition force on the bolt due to external load P. Addition force due to external load P, it is given by C into P. This is external force due to application of load P, where C is known as, my dear friends, C is known as joint stiffness constant. Stiffness constant, joint stiffness constant, and that value is given how much, my dear friends? I think it is given 0.2. P is applied load, this is applied load. So from there we can say, sir, Fe is coming out to be how much, sir? 0.2, and applied load is given 10,000. Yes sir. So by that you are getting how much? 2,000 Newton is coming out to be. So what is the total force? Total force we can say, total force F total is equal to F of I plus F of E. It is coming out to be 20,000 plus 2,000 is equal to how much thousand? 22,000. 22,000 is your answer. So what the answer is, dear my dear friends? 22,000 Newton is your answer. So C for Chennai is the right answer. So as I told you, you have to be think, then only you could be able to solve the question. Now coming to the next question. See, that is a great question, yeah, really mind-blowing question. Mind-blowing question it is, and real life incident like that question is going to be asked in ISRO. If you are by hearting the things, you don't know the exact cause, then yes, you will find difficulties to solving that question. Read that question, my dear friends. You have 1 second of time. What you can say? See, in an accident site, tire mark shows that a car was traveling along a straight level street skid for a total distance of 23 meter. Well sir, after the brake applied, the coefficient of friction between the tire and the road estimated to be 0.5. Fine sir. What was the probable speed of car when brake was applied? It was a real life situation. You are driving your bike or car, suddenly you are going to apply the brake, and after the application of brake, still your vehicle is going to move how much meter? 23 meter. So the question is that, what was the speed when suddenly brake is applied? That was the question, and really beautiful question it was, and you have to be think like a scientist, then only you could be able to solve the question. Really good question, na? You are, suppose you are driving a car, suddenly something is coming and you are going to sudden apply the brake. Even application of brake, there is a skidding, and due to the skidding, your vehicles or your car is going to move the 23 meters. So now the question you have to be calculate, what was the speed when the brake was applied? That you have to be calculate. Yes sir, getting sir. So how I can do that, sir? how I can do? How you can do, my dear friends? Anybody can tell me what will be answer? Can you try? Can you try? Okay, see the question. So sir, in this question, just listen, first leave the data, write the data, then start thinking. Rather than leaving the question, write all the data. What the data, sir? What the given data, sir? In the question, in accident site, the tire makes mark shows that car was traveling along a straight level skid for a total distance of 23 meters. So after application brake, how much meter it is going to move? Sir, it is going to move for the 23 meter. Fine. After the brake applied, the coefficient of friction between the tire and the road, suppose that was the road and that was your vehicle tire. So here coefficient of friction is known in the question, and that value is coming out to be how much? The coefficient between tire and the road estimated to be 0.5. This is coming out to be 0.5. What is the probable speed? So what was the probable speed when the brake is applied, that one? So how you can do that, my dear friends? No, just think out. Sir, just say, when the brake is applied, na sir, when the brake is applied, after that vehicle is going to be stopped. So which one force is responsible to stop the vehicles? Obviously sir, frictional force. If there would not be frictional force, body will continuously going to be skidding to the infinite length. Because of that friction force, body is going to be stopped. Yeah, right sir, right sir, right. If there is no no roughness is there, no friction is there, even if you are going to be suddenly apply the brake, your car is going to skid. For how long distance? Infinite distance they will cover if there is no roughness, no friction. Yes sir, right. So sir, the thing is that the vehicle is stopped because of which force? Obviously because of the frictional force, right sir. So what is the frictional force, sir? Sir, frictional force I know. Frictional force is what? Mu into n, na sir. And suppose this is a car, so what will be? In the upward direction, and in upward direction you can apply the n, and downward is what? Here you can say mg. So frictional force is equal to what, sir? Mu mg, right sir. Frictional force equal to what, sir? Mu mg, right sir. In the question m is known. Okay, not known, no need to worry. Okay, fine, getting sir. Sir, now tell me one thing, sir. Once I suddenly apply the brake, so it is accelerated or retarded? Obviously sir, it will be retarded, sir. It will retarded. Velocity decreases, so it will be retarded. So can I write frictional force will also equal to what? M into A. Yes sir. Now tell me, from there can I say M into A is equal to mu mg, right sir? I can say. So sir, m will get cancel out. What will be acceleration? It will be mu into g, sir. In the question, mu is also known, g is also known. Now the question is that why I am going to be calculate u A, sir? Why I am going to be calculate A? Yes, my dear friends. My dear friends, in the question, s is known, your final velocity is known, and you have to be calculate initial velocity, right? Yes sir. So can I write v square equal to u square plus of 2as? In the question, final velocity is 0. If I get the A, in the question, this displacement is given, can I calculate u? Yes sir, I can, sir, I can. That's why, my dear friends, I have to be calculate the A. And A, how I can calculate? F is equal to mu mg, and that force is only applicable here to retard the motion. So F equal to ma, I can say from the Newton's second law. Yes sir, getting sir. So from there we can say what the value of A is coming out to be, my dear friends. Just put the value. A will be equal to mu is how much? It was 0.5. Let me check. So how mu it was? Okay, 0.5. Okay, 0.5. And simply, yeah, in your exam calculator is not there, so you can use the G10, right? Just use 10, so it is coming out to be 5 meter per second square. Now put the value is there. So sir, it will be 0 equal to u square plus of 2, but A will be minus. A will be minus. Why sir? Because it is retarded. So minus 5 into s. So from I can say, sir, u square equal to 2as, u equal to 2a 523 under bracket under root, and by solving that you will get approximate how much it is coming out to be. By solving that, 54 point something. By that you will get u is coming out to be 15 point something. You can check out. This is meter per second, but in the question it is given in the kilometer per hour, because a speedometer that is connected in your vehicle, it shows in the kilometer per hour. So option is given in the kilometer per hour. So let us convert that in the kilometer per hour. So this is meter per second. Simply we can say sir kilometer, na sir. So 15.2 kilometer. So it will be kilo, na. So 1 upon 1000. But this is second. To convert in the hour, just multiplied by 3600. That was 1. And by solving that, how much it is coming out to be? Approximate 54.036 kilometer per hour. It is coming out to be 54. What answer is there? Yes, the answer is A for apple. The answer is what, my dear friends? A for apple. So what was the approach to think? First you have make a draw whatever has been given in the question. Believe on your concept and you have must positive attitude. First you have to think, okay, this vehicle, when the brake is applied, after the skidding takes place, so vehicle will stop only because of the friction force. Friction force equal to mu n, this is equal to mu mg, and this will be also equal to ma. So A. Why I have to be calculate A? Because sir, I have to be calculating in the question u, initial velocity when brake was applied. So you know sir, it is given by v square equal to u square plus up to s, but here plus will not be there because it is not accelerated, it will be retarded. So minus A is coming. Once I get the A, I can calculate. So from there I have get the A, and accordingly I have get the answer. So like way we have to be think, rather than ki oh just seeing the question and oh yaar tougher question I can't do. No, you can, you have a potential, but you must have to be positive attitude. That most important in the exam. Coming to the next question, my dear friends, that is the next question, and yes, that is also great question here. Really ISRO is going to ask a great question, and you know why? Because you are being a scientist, you have to be thinking, See the question, great question, it was a really excellent question. The question is that in a solid cylinder, if a solid cylinder, thin hollow cylinder and a sphere, fine, all with same material and having same outside diameter, allowed to roll down in a same inclination without sliding, fine sir. All surfaces are having same coefficient of friction. What is the order of the bodies reaching the bottom? All reach together, solid cylinder, sphere, thin hollow cylinder, sphere, solid cylinder, thin hollow cylinder, thin hollow cylinder, solid cylinder and sphere. That is the question. What will be the answer? So just think the question first and start thinking. Okay sir, I have to be start thinking. A solid cylinder, suppose sir, like that, this is the like that, okay, and here three things. One is solid cylinder, a solid cylinder, thin hollow cylinder, this is a sphere. One is solid cylinder, one is hollow cylinder, okay, like that, having outside diameter allowed to roll. Now these all are allowed to roll over that one. Suppose if I am going to leave all these three at the same time, so now the question is that, which will come fast at here, which will come faster, or which will come first at that their level? That is the question. You know, in this question what is happening, most of the student is making option A, my dear friends. I have seen in the previous, whenever I am going to take in the class, they are going to be answer A, but that is wrong answer, my dear friends. This will be only when if the rectangular block is there and mass different. If in this situation we cannot say it will be the answer. So first of all, now tell me which will come here fast. Sir, I can say the body having high acceleration will come faster, because you know V is equal to U plus 2AS. Okay, so sir, U is 0 for all the body. So sir, S is same, that distance is going to be travel, so S is same. So sir, any body have A will be higher, it have higher velocity, so it will come fast here, it will come first. Sir, right sir, A will be higher, it will come first. Now the question is that how I can calculate the A in that case, my dear friend, how I can calculate A. So my dear friends, I want to just give one formula to calculation of A in this situation. If you can remember, it is well and good, otherwise no need to worry. Last conclusion I will tell you that you have to remember G sin theta upon 1 plus I upon mr square, that is the acceleration that you can get, G sin theta upon that one. Now my dear friends, I is what? Moment of inertia. So you know moment inertia for all, what will be I for solid cylinder, it will be half mr square. What will be I for hollow sphere? I for hollow sphere, do you know anybody? mr square. And what will be I for sphere? Sphere, try to remember, it is 2 by 5 mr square. Now put that value here, and by solving that we will get, my dear friends, by solving that, just put that value there, and by solving that we will get A of solid sphere, A of solid is coming out to be 0.66 g sin theta. In case of A of hollow sphere, hollow cylinder, not sphere, it is coming out to be, I think, how much, 1 upon 2.5 g sin theta. And if you talk about A, in case of sphere, that value is coming out to be 0.7 g sin theta. Now tell me, my dear friends, which have higher A? So sir, sphere have higher A for the same mass, everything. So sir, first of all, I can see here A of sphere is high, so it will come first. After that, A of solid will come first. After that, A of hollow. So material having higher A will come fastest. So the correct answer will be what, my dear friends? Here we can say, sir, first of all a sphere, after that solid cylinder, after that thin hollow cylinder. So correct answer will be C for Chennai. And yes, that was the good question. Generally a student is going to be stuck in that type of questions. But as I told you, you have to thinking capability like a scientist. All the problem you have much positive attitude, easily you could be able to solve that question, all that type of question, nothing tougher. Chalo, come to the next question. Yeah, that is the next question. A 0.2 mm, okay, that is the question of the gate, that type of question has been asked. That question is related to gate. A 0.2 mm thick strip is bent and laid over a frictionless pulley of 25 mm diameter. If E is 100 gigapascal, the maximum stress in the strip, and these all are given. My dear friends, easy question. You can see. Suppose that is the one of the ruler, or you can say pulley. Over that, that is the belt or rope, whatever you can say. Don't go on my diagram, but just listen, try to understand the visualized things. That is the diagram. Okay, sir, in the question thickness is given, na sir? In the question that thickness is given. Yes sir, that thickness is given. How much sir? 0.2 mm sir. 0.2 or 0.02? Oh yes sir, 0.2 mm is given, and E is given here sir. How much? 100 gigapascal. The maximum stress. So it is bending, na sir? What is the equation of bending? Anybody can tell me? Anybody can tell me equation of bending? Yes, you can. Yeah, you are engineer. Sir, M upon my engineer whom? E upon R sigma B upon Y. That is the equation of bending, sir. And in the question I have to be calculate sigma maximum, sigma B I have to be calculate. So sir, can I say? What can I say? Sir, in the question E and R, radius is known, no sir? In this question E and R, so can I say sigma B is equal to E Y by R? Yes sir. So sigma B, what will be Y? Sir, this is, so there will be one neutral axis, na yaar? Yeah, there will be one neutral axis. Yes sir, this is neutral axis. This will be the neutral axis, and from the neutral axis what will be Y? Outer fiber, na? Maximum stress will be outer fiber. Either it is outward or inner. It will be on the outermost fiber. So either there or there. So you can say Y is equal to how much sir? 0.1. Y is equal to 0.1 mm. Just put the value and you will get the answer. Sigma B is coming out to be, in the question is known there, how much sir? 100 giga is given sir. So 100 giga, so 100 into 10 to the power 9 into Y. Y is 0.1 na? I am going to write there. I am going to write here. Sigma B is equal to 100 into 10 to the power 9 into Y is given 0.1. Okay, make in the 0.1 mm, or answer is given in the megapascal. Okay, no problem. 0.1 mm, 0.1 into mm will get cancelled out because in the denominator also mm is coming out to be upon what? R. So 12.5 my dear friends, because diameter is given na here, diameter is given na, diameter is given or R is given, frictionless yes, diameter, so 12.5. just solve that value my dear friends, just solve that value. By solving that, I think how much it is coming out to be my dear friends, by solving that we will get the value is coming out to be 800 megapascal. 800 megapascal is coming out to be answer, and it was I think easy question and the student can do that, but the thing is that they must have to remember the bending equation. If they don't know how to use the bending equation, they cannot be able to solve that one. Okay my dear friends, great, you guys have really lot of patience. Good. Now if you have a lot of patience, so I am coming to the next question, and yes, this is again a good question, but before that I am going to be take another question, then I will come on that question. Okay, let's move with that question. Where is the question? Okay, let's start with the same question, then I will come. One important question is there, the concept that I have discussed just now, it is related to the same question. I think it is very far, so let's move in the sequential manner, no problem. So that is the next question on your screen my dear friends. I am going to be little bit zoom out, right. The question is that a 500 diameter solid shaft is welded to a flat plate all around by the fillet weld of 4 mm leg size as shown in the figure. Fine. If the allowable shear strength of the weld material is 100 megapascal, the maximum approximate torque in Newton meter that the weld joint can sustain under pure torsion, and the option you have 500 pi upon root 2, 1000 pi upon root 2, and since calculator is not allowed, that's why they have left it option in that format, and you have to be answer. See how we can solve that my dear friends. Just start thinking, don't be trapped in the language of that question. Okay sir, a 50 mm diameter solid shaft welded to a flat plate. This is the flat plate my dear friends, over the like that, suppose that is a flat plate, upper that you are going to weld that object now. So this is something like that, you are going to be weld it like that. So a 50 mm diameter solid shaft is welded to a flat plate all around by fillet weld of 4 mm leg side. This is joint is what? Fillet joint, and the leg size is given 4 mm. If the allowable shear strength of the weld material, allowable shear strength, the maximum shear strength that weld material that they can sustain is given 100 megapascal. Well sir, the maximum approximate torque, no, you have to apply the torque there. We can see here one torque is applied there. Can you anybody tell me what is difference between bending and torsion? What is difference between bending and torsion? When the torsion is coming my dear friends, whenever suppose that is the plane of cross section here, this is the cross section, whenever the movement along the cross section of the object, suppose that is the cross section and movement is like that movement, then it produce twisting. But if the movement is in anywhere in the longitudinal axis equal and opposite, then it gives bending, then it gives what my dear friends? Bending. So now see my dear friends, we can see sir in the question here the maximum approximate torque of welded joint, in the question you have to be calculate the torque. So what will be the equation? First you have to be know what will be the equation of twisting. So simply we can say sir, I know T by J G theta by L equal to tau by R, right, tau by R, that is the equation of torsion, or you can say twisting equation. Sir in this question I have to be calculate the T, in this question tau is known sir, R is known, so can I say T is equal to tau J upon R? Yes sir. And in the question tau is known sir, in the question shear stress is known sir, maximum that they can withstand 100 MPa is known sir. In the question radius is also known, how much sir? 50 mm diameter, that means radius is also known 25 mm. But sir if anyhow I am able to calculate the J, this is called polar moment of inertia. J is called is what my dear friends? Polar moment of inertia. If anyhow I am able to calculate the J, I I will get the answer. That is the only things you have to be do. That's why when read the question, now the question is that how I can calculate the J. So my dear friends, polar moment of inertia for circular ring J is given by A R square. In the question, sir, R is also known. Sir, now the question is that I have to be calculate the area of the weld. So what will be the area of the weld, my dear friends? Area of the weld will be, A is what? Area of weld. Area of weld, it is given by throat into weld length. What? Throat into weld length. Weld length, na, simply we can say, हाँ sir, weld length. So what will be throat? What will be throat, my dear friends? Throat is always given by T is equal to H into 1 by root 2, or we can say H by root 2. H is given how much? Leg height is given here. In the question, leg weld, fillet weld 4 mm leg. So H is known here, sir. How much? 4 mm. So it will be 4 upon root 2. Leave, don't solve that one, because ultimately in the option you have to be calculate in the form of a root 2 itself. So leave that one. Okay, so thickness is known. Sir, what will be A? What will be area? So area will be, sir, T into what? Weld length. So weld length, it will be pi d, na sir. Weld length, suppose this is circular, na yaar, here is a circular, na. So what will be length? Circumference, simply we can say circumference. If you are going to be cut them, and I will tell you what will be the length. So circumference will be what? Pi d. Circumference will be the pi d. So just put that value here, pi d. Sir. So by doing that, I will get some. So T into pi d. So thickness 4 upon root 2, and pi, leave the pi, and d is given how much? 25 or 50? 50, na? D is given 50, na? Yes sir, 50 is given. So from there, just put the value 50. So A is coming. What will be tau? Tau will be AR squared, sir. So A is 4 upon root 2 into pi into 50. R is given again how much? Simply we can say R is, sir, 25 mm, na? Yes sir, 25 mm there squared. Now put that value. Yes, here see, my dear friends, in this question we can say, so lot of calculation is there, sir. Without calculator, now it will be very tedious to solve the next step. Now if no calculator is there, putting that value and you are going to be cancel out, obviously it will be very complicated, and no. So not all data for, so that's why, my dear friends, I used to say little bit work on your calculation speed, because in the gate or in the college day, all engineers are being habitual to use the calculators. Even they will ask what will be 4:2, they are going to use the calculator. So if you are totally dependable on the calculator, so little bit work on that and try to solve the question without calculators. That will help you a lot in the exam. Otherwise, my dear friends, will stuck like that. They type, yeah, I know that is a complicated calculation, but you have to do na yaar. How many questions you can left for the calculations? If you have to be selected, you have to do something different na. So do that, yaar. So my dear friends, I have answer because I have used this, I have made all the calculations, and by solving that, T is coming out to be, put this value, it is coming out to be 500 pi upon root 2. 500 pi upon root 2, it is coming out to be answer by putting all that data. So the 500 pi upon root 2, it will be the A will be the coming to the right answer. Great. Okay. Coming to the next question. What is the revolving joint of the robot called? So that question is a theoretical question, my dear friends. Simply we can say, right, this is called is what? Revolving joint of the rod is known as, simply we can say, T joint. So simple theoretical is that, you have to be just remember. Now my dear friend, that question is again has been taken from the subject, you can say, machine design. In the class I used to discuss, and hopefully that was direct straightforward question, and the student who have prepared, they can do that, no problem, they will not find any problem. If anyone have prepared for the exam, they will not find any difficulty in that type of question. The diagram below showing the various criteria for a fatigue failure. Which option is the correct representation of these criteria? Subscript E, Y, U represent endurance, yield, and all that the value is given there. My dear friends, most conservative theory is known as Soderberg theory, right? So one will be always Soderberg. One will be Soderberg. So sir, answer B and D can't be, sir. No. After that, 2 will be the Goodman and 3 will be the Langer line. Now 2 will be the what, my dear friends? 2. This is called Goodman, and third one is called Gerber parabola, Gerber line. So A will be the right answer. 1 Soderberg, 2 Goodman, and 3 is the Gerber parabola. So A is the right answer, my dear friends. Huh? What is the option A? Huh. So easy question it was, easy, really it was easy question, and everyone who have did that, they can solve that. No, that is the next question. Question is that a 20 mm diameter aluminum rod is turned to 19 mm diameter in a single pass. Well, if the axial speed of the tool is 200 mm per minute, okay, and the spindle rotate at 600 rpm, the material removal rate nearly, and the option you have 61,000 mm3 per minute, 12,250 mm3 per minute, 3050 mm3 per minute, 9150 mm3 per minute. That the option you have, my dear friends. How you have to be proceed? See, a 20 mm diameter aluminum rod is turned. This is a turning operation, has been taken from the production engineering. One topic you might have gone through, metal cutting. So that question has been taken from the metal cutting. Specify if you want to be, you can say from the turning operation, right? Okay. So a 20 mm diameter aluminum rod is turned to 90 mm diameter in a single pass. Okay. So my dear friends, thing is that suppose that initially that was your aluminum rod and the diameter is given, my dear friends, 20 mm, right? The diameter is given 20 mm, and you are going to be use here one turning tool operation, right? That is the turning you are going to be used there. After turning, kahani is happening something like that. Now this is the things, right? Okay, not okay, that has been turned out, turning is done, that is your tool. Okay, that is your what, my dear friends? Tool. Okay, fine, that turning operation. And you know, my dear friends, in this direction this velocity is called what, my dear friends? We can say feet. And in the question what you have to be calculate? You have to be calculate, simply we can say m, what, material removal rate, na? The material removal rate is nearly. So what will be material removal rate? First of all, tell me, my dear friends, what will be depth of cut? So this is depth. What will be depth of cut? If I will ask, D is called depth of cut. Depth of cut. Let's assume, my dear friends, this is R1. This is what, R1, and this is what, after the cut, this is R2. So depth of cut will be what, my dear friends? Simply we can say, sir, R1 minus R2, or you can say D1 minus D2, or you can say the D1 minus D2 upon 2, or we can say R1 minus R2. So it is coming out to be R1 is 10 and R2 is how much? 9.5. So it is coming out to be 0.5. Okay, what will be material removal rate? What will be the material removal rate? So we can say, sir, material removal rate is will be simply area into velocity. Always, yaar, whenever you have to be require rate, na, material removal rate, discharge, area into velocity. So what will be area, sir? Pi R1 square minus of R2 square. What is the velocity? In the velocity, this is given, na, how much? 200 mm. How much? 200 mm per minute. If the axial speed of the tool is how much? 200 mm per minute. That means in 1 minute they are going to move how much? In 1 minute they are going to move 200 mm. So 200 mm per minute. So leave in the mm per minute. Just put the value 200 mm per minute. Ultimately you have to be get the answer in the minute. So leave that. Now put the value pi. What will be R1, my dear friends? 10 square minus of 9.5 square into 200. Now little bit calculation is there. So pi. We can say, sir, 100, 81, and by doing that we will get 90.25. Little bit calculation, as I told you, you have to be do, you cannot skip. And by solving that we will get 6126 mm3 per minute, but in the option that is not present. So accordingly we can say in the option it is coming out to be 6100 meter cube mm cube per minute. So that is the material removal rate, my dear friends, and it is coming out to be how much? So what will be answer? 61. So whenever, see in the option mm cube per minute, now see from the option we can guess mm cube per minute. Mm cube means volume, per minute means volume is what? Area into velocity. So from the option you can think, okay, something I have to do the area into velocity, then only I can get the mm cube per minute, right? So area into velocity, simply do na yaar, don't think much more, huh? Right? In the go through the option, I know, okay, suppose you don't know, sometimes it's happen, but through the option we can answer. We can think, sir, all option are mm cube per minute. How it will coming, sir? In the fluid mechanics you used to teach me, sir, discharge meter cube per second. Okay, minute is there, no problem. So area into velocity, sir, area is that, na sir? Okay, that will be turning, na sir? So area will be what? Area we can calculate whatever is turned out in a single pass that has been completed. So final minus initial, right? And velocity is given 200 mm per minute. That means in 1 minute they will move 200 mm. That is axial velocity. Now just put that value and off, and after that we'll get the answer. No problem is there. Yes, that is the, my dear friends, really good question. I appreciate that question. The concept has been used in that one, and I will tell you, you can solve that question fast. If you can solve, take the attempt, then rest we will see. See. Okay, I know, by watching the diagram a student is getting feared. Okay, sir, how I can solve that question? Just use the concept and your mind and yes, positive attitude. These three things: concept, mind and yes, positive attitude. If these three things you have, if anything is not there, you could not be able to solve. If you have these three things, very easily you could be able to solve that question. Okay, sir. So what that thing is, sir? First lead the question. A small ring Z carry vertical load A of mass 27.3 kg. A mass is given, my dear friends. Mass of A, or we can say the mass of A is given here 27.3 kg. Well, by two strings Z x and Z y. So that is Z. So Z is Z x and Z y. A string xy carries a load at B xy. A string xz, not y, carries load B at its free end through a frictionless pulley. Fine, here we can see there. Find the value of B round to the nearest integers if the string is stable and the configuration shown in the figure, that the diagram you have. Now start thinking, what the concept behind that, my dear friends? In the classroom I used to say always that one thing you have to be keep in mind, my dear friends. If there is a single string, na, tension will be same throughout. Just start thinking, sir, in this question I have to be calculate the find the value of W. Sorry, M means I have to be calculate the mass. Mass, na? Yes, I have to be calculate the mass of B. Sir, I have to be calculate the mass of B. Okay, sir. Right. Yes, sir. Now I start thinking how I can do, sir. Okay, start thinking how I can do that question, sir. Sir, I have to be calculate mass of B. Right. If I come to the point, na sir, so in the vertical direction, M B into G will act, sir, right, and upward direction the one tension is coming, sir, one tension is coming. If anyhow I am able to calculate that tension, so I can say, sir, this T is equal to MB into G. Yes, sir, right. And anyhow if I calculate that T, sir, G is known, I will get the MB. Right, sir, that is only approach I have to do. Now the question is that how I can calculate that tension here. Sir, right. Sir, if you see 3, so ZY and this is a single rope, na sir? Sir, single rope. So in a single rope, tension will be same everywhere. Right, sir. In a single rope, tension is same everywhere. So sir, let's assume I am going to be tell this is tension T1, this is tension T2, right? And that is the mg. We can say here the weight is acting here. Mg is how much? 27.3, and G take here 10. G, you can, I have used the calculator, so I have used 9.1, but in the exam calculator is not there na, so you can use the 10. Okay, I have used the calculator, that's why I put the 19.8 or 9.8, sorry. Now sir, what I have to do? Sir, body in the stable na sir, in the question it is given that body in the stable equilibrium. So can I say sir, if the body in equilibrium, so can I say summation of all the force in x direction is 0 and summation of all the force in y direction is 0? Huh sir, then only body will remain in the equilibrium and statics condition, right sir? So now break the component in the given diagram. Suppose this is T1, so what will be their component here? What will be their component? So this one will be T1 sine of 45, and sir this one will be the T2, so T2 sine of 60, sine of 60. So sir, can I say, if I am going to use equation summation of all the force in x direction 0, so can I say what, minus T1 sine 45 plus of T2 sine 60 is equal to 0? Yes sir. So from the equation I can say कि sir T2 sine 60 is equal to T1 sine 45. Let's assume equation number first. Let's assume it is a equation number first. Now sir, can I say Fy is equal to also 0 sir? Fy is also equal to 0 sir. Summation of the force in y direction is also 0 sir. So what will be y direction? So we can say sir T1 cos of 45, T1 cos of 45 plus T2 cos of 60 in the vertical direction yaar, minus 27.3 into 9.81 is equal to 0. So can you get the equation number 2 from there? We can say yes sir, T1 cos of 45 plus of T2 cos of 60 is equal to 27.3 or into 9.81, whatever is coming out to be 20.3 into 9.81. So my dear friend, that is equation number 2. So from the equation number first and 2, can you get relation between T1 and T2 or not? Yes sir, I will get the relation by the solving the equation T1 and T2. By solving the equation first and second, I will get the relation T1 and T2, put that relation in there, and after doing that my dear friends, I am coming to the right there that value. After solving that, the value is coming out to be T1 is equal to here, T1 is equal to coming out to be 1.225 T2, and further by the equation that one, put that value in the above equation, and by putting that value we can say the T2 is coming out to be how much? 196.05 Newton. 196.05 Newton is coming out to be. And now my dear friends, use that concept there. T equal to mg into b. So T2, this is your my dear friends T2 because of single string. So can I say T2 equal to mb into g. So what will be the mb? So it will be 196.05 upon 10, or you can say 9.81, but 10 will be g. By solving that, the value is coming out to be approximate 19.98, or we can say the 20 kg. So the what answer is coming out to be my dear friends? It will be the 20 kg. So what the answer? Bombay is the right answer. So that's why my dear friends, there is nothing that you don't know. You know all the things, but where you have lag? You lag by applying the concept, or some hypothetical pressure appears on you that you cannot solve the question and you have left it. So if there is anything new that I have teach you, but the concept that you know from the very earlier, same thing I have used there. That's why practice and positive attitude is most important in your selection, my dear friends. Really most important. Your positive attitude is most important here. So simply I have just do the balance, but yes, one concept is there. In a single string, the tension will be same throughout. That is only one concept that you have to remember. Rest thing will come automatically, right? Okay. So my dear friends, that is the next question. And try to solve that question. You have a few seconds. The question is that an aluminum ring of mean diameter of 5 meter at ambient temperature. Okay, an aluminum ring of mean diameter of 5 meter at ambient temperature is dipped into a liquid nitrogen bath. Okay, liquid nitrogen, you know, na, temperature is very very less here, na, liquid nitrogen very very less will be temperature. Okay, what will be the mean diameter of the ring in LN2 bath, nitrogen bath? Okay, the coefficient of linear expansion of aluminum alloy in temperature range may be taken as 20 into 10 to the power minus 6 per Kelvin. Ambient temperature may be taken as 24 degrees Celsius. Boiling temperature of liquid nitrogen is coming out to be 77 Kelvin, and that you have to be used. You know, my dear friends, see, you have an aluminum ring of mean diameter 5 meter. So suppose that is an aluminum ring you have, my dear friends, right? And the mean is here, you can say 5 meter. Well, temperature, now you are going to be deep in the nitrogen. You know, nitrogen temperature very very less. So you are going to be deep now in the bath in which nitrogen content is there. Cryogenic engineering you might have listened, no? Like that. So nitrogen content is there, right? And in the question, the coefficient of linear expansion alloy temperature may be, so alpha is also known, my dear friends. How much? 20 into 10 to the power minus 6 per Kelvin, or you can say ambient temperature may be taken as when it was in the atmosphere, their temperature was 24 degrees Celsius. In the question it is mentioned that when, since this aluminum was initially in the ambient, so it was 24 degrees Celsius. So what the question? Mean diameter is itna. What will be the mean diameter of ring LN2 bath? Now what will be the mean diameter after putting in that one? What will be the mean diameter when I am going to put in that one? So simple we can do, my dear friends. Can you do? Yes. So what will be, let's assume, what will be T naught, final temperature? What will be T naught, my dear friends? So we can say, so T naught is coming out to be 24 plus 273. So by solving that, you will get 297 Kelvin. 297 Kelvin. Okay, yes sir. Sir, what will be change in dia, sir? Okay, what will be delta T? What will be delta T? Delta T we can say, sir, this is 297 and this is 77, right? So what will be delta T? Final minus final temperature is 77 and initial is 297. This is the final temperature. Boiling temperature liquid nitrogen 77 na? So final when you are going to put them, so it will be final temperature 77, initially was 297. So by solving that, how much is coming out to be? Minus 220 Kelvin. Okay, why I have used that, sir? Because I know change in diameter is given by D naught into alpha into change in temperature. So sir, this is D naught. In the question it is given out 5 into 20 into 10 to the power minus 6 or into minus 220. Now it is going to be contract, not expand, because temperature is decreases, right? So change in diameter, by solving that, this value is coming out to be how much? 0.02 meter. So you can say, sir, what will be final dimension? What will be the final diameter? In the question, final diameter is calculated. You have to be calculate. So simply we can say, sir, di minus d naught is equal to change in diameter. So in the question, change in diameter is known, sir. So df final diameter minus that one. So our final diameter will be do plus of change in diameter. So do is 5 minus of 0.022. By solving that, we will get 4.978. So the answer will be 4.978. 4.978. 4.978. Very close answer. Such a close answer should be there without calculator. Very close answer is there, my dear friends. So simply even now you can eliminate the option C can't be. Why? Because temperature decreases so it is not going to be expand, it is going to be contract, because temperature decreases, so it is going to be contract rather than increasing. Okay, getting? So that thing you have to be just keep in mind, my dear friends, how you have to be proceed. Okay, and in this question the main thing that you have to be just here keep in mind, it is going to be, what it is going to be, simply we can say, sir, it is going to be cooling down. So if you are going to be cool anything, their diameter decreases rather than increasing, right? So by that we also can make a conclusion. This is called cryogenic, fuel also cryogenic, the thing which exists at a very low temperature. Cryogenic concept is also there. So okay, that is the next question, my dear friends. A journal bearing of radius r1 and radial clearance c1 has a Sommerfeld number s1. Another journal bearing of radius r2 and radial clearance c2 has Sommerfeld number s2. All other parameters remain same for both the bearing. If r2 equal to 2r1 and c2 equal to c1 upon 2, then s2 upon s1 you have to be calculate that things, my dear friends. You have to be calculate that things. So that question has been taken again from the machine design. One topic is there, bearing. So that question has been taken from the bearing. The question very simple. A journal bearing of radius r1. Okay. See, my dear friends, suppose that is your bearing, right, and that one your journal, that is the O node, and this is their center, and this gap is called clearance, my dear friends, right? This is called radial clearance c1. This is called radial clearance, right? So journal bearing and their radius is r1 in the question, and radial clearance c1, and Sommerfeld number s1. Their Sommerfeld number is s1. Fine. Another journal bearing, there is another journal bearing, right, of radius r2, radial clearance. Now this is the bearing. Now their radius is r2, and let's assume this is their center, this is their center. Now their clearance is given in the question c2. Well, another journal bearing of radius r2 and c2 has a Sommerfeld number s2. Now their Sommerfeld number is what, my dear friends? s2. All other parameters remain same for both the bearing. Rest parameter is same. The only condition, if in the question they are going to be say, sir, r2 equal to twice of r1 and c2 is equal to c1 upon 2, then the relation you have to be calculate. Sir, I have to be calculate s2 upon s1. I have to be calculate. Bas. That is the question. Now start thinking. First of all, you have to understand what is Sommerfeld number. If you don't know Sommerfeld number, you cannot step in single step now. Right? So first of all, you have to know, sir, what is Sommerfeld number. So Sommerfeld number is given by S is equal to mu n r square upon pc square. That is the Sommerfeld number is given by mu n r square upon pc square. What mu? Mu is dynamic viscosity, or you can say coefficient of viscosity. N is rpm, revolution per minute, or you can say rotational speed. R is journal radius, P is bearing pressure, C is radial clearance. C is here what? Radial clearance. Radial clearance, and R is what? Simply I can say R is what, my dear friends? Journal radius, journal radius, journal. So now see, my dear friends, now we can say, sir, in the question it is saying that only radius and clearance is going to be changed out. Rest parameter are same. Rest parameter are same, means mu and p, that all are same. Only radius and clearance is going to be changed. So can I write? Can I write like that, my dear friends? Tell me. S is equal to something constant, r square upon c square. Right, sir? Yes. So can I write S equal to proportional to r upon c whole square? Why not, sir? Yes, r upon c square. Right. Can you say? So can I say, sir, S1 C1 upon R1 whole square is equal to S2 C2 R2 whole square? Yes, sir, I can, sir. Why not, sir? Obviously I can. What I have to be calculate, sir? I have to be calculate S2 upon S1, right? S2 upon S1 I have to be calculate. So S2 upon S1, what the value is coming out to be, my dear friends? S2 upon S1, right? S2 upon S1 or S1 upon S2? What need to be calculate? S2 upon S1, right? So it will be what, my dear friends? S2 upon S1. So it will be C1 upon R1 square into, you can say, sir, R2 upon C2 square, right? So just put that value here. Simply we can say sir C1 upon R1 R2 upon C2, just put the value and there squared, put the value by coming that it is coming out to be 4 chi squared, it will be 16. So simply we can say sir S2 equal to 16 times of S1. S2 equal to what, my dear friends? 16 times of S1. So what the correct answer? 16. Yeah, the ratio you have to be just calculate, not you have to multiply, you have to be just calculate the ratio, and after that we will get the answer, that ratio it is coming out to be, right? Yes, my dear friends. So now let's just take that question. So what is that question? Question is that this is a match of the following, column 1 and column 2 you have, and column 1 is theory of failure, and basically the shape is given in the column 2. We can say a theory of failure, a Rankine theory, and the shape is what, you have to match that one, right? So yeah, that is a easy question. We can think out, if you know the value, you can solve it very easily. You don't have to be think like a scientist in that question. Even you can solve by normal thinking. If you know the theory, you could be able to solve very easily. If you talk about, my dear friends, Rankine theory, if you talk about Rankine theory, then this is applicable for what material, my dear friends? This is applicable in case of brittle material, known as maximum normal stress theory. This is also known as, right? If you talk about Tresca theory, this is known as maximum stress theory, basically applicable for the ductile material. Saint Venant's theory, basically maximum principal strength theory. So that all are right. If you see what will be Rankine theory, so yes sir, Rankine theory will be the squared. Rankine theory will be the squared. Now go through the option. Only one option is there, C4 Chennai would be the answer, right? You know, my dear friends, if that type of question is going to ask now, so you have one edge. What is that? That question could be solved, more probably you will get the right answer, because in this question, suppose if you don't know all, what is the actual shape of all this theory, just whatever you know, suppose you know the Rankine theory is squared, just go through the option. Only one option is there, see A match with the third, and you will get the answer. If you talk about Tresca theory, yes, it is being hexagon, right? This is being hexagon. Saint Venant's theory, if you talk about, so it is rhombus, and this is what, ellipse. So if that type of question is going to ask, my dear friends, so try to eliminate the option and you will get the answer. Yes, my dear friends, that is the next question has been asked, and yeah, that is also easy question. So not all the question will be tougher, some question will get easier also, like the last question and that question. The question is that the moment of resultant of concurrent force with respect to center of their plane is equal to algebraic sum of the moment component with respect to same center. This theorem is known as theorem Weismann's method. You can say Weismann's theorem, method of moment, theorem of equilibrium of active forces, or theorem of three forces. My dear friends, that is the what Weismann's theorem. If you have remember, basically that talk about the Weismann's theorem, that the moment of all the force about a fixed point will be equal to the moment of their resultant force about the same moment center. So that is nothing but Weismann's theorem. So you can say na, moment of resultant of concurrent force with respect to center, their plane, in their plane is equal to algebraic sum of moment of component with respect to same center, and this is known as what, my dear friends? Weismann's theorem. That question has been asked from the engineering mechanics, and easy question it was, you could be able to solve very easily if you know the theorem. Now that is the next question, and the question is that strain curve for stress strain curve for three types of material is given in the figure below. Fine. Please identify the correct combination. You have to identify the correct combination, right? Here E, F and G is given. My dear friends, if you go through the E, we can say this is going to be fracture at a very less, we can say change in length, or you can say strain, you can observe is a very, very less. If anything is going to fail at a very, very less strain, then obviously that material is known as what, my dear friends? Brittle. So we can say, sir, E will be, sorry, this is E na, so it will be brittle material, sir. This will be what? Brittle material, right? If you talk about F, so yes, there is a permissible deformation, after that it is going to fracture. So yes, it will be what, my dear friends? That will be ductile material. Ductile, this is a ductile material. Now my dear friends, if you talk about G, right, G is what? This is like that. Strain is what? Continuous going to be changed. strain is continuous going to change at a given stress. That type of material is called is what? Ideal plastic. That type of material, that means at a given stress continuous deformation is going to be takes place. We can say ideal plastic object or ideal plastic body. So we can say, sir, this is the ideal plastic, or we can say of according to the option plastics, right? So what will be answer, my dear friends? E brittle, F is ductile, and G is plastic. Yes, A for apple is the right answer. A for apple is the right answer, right? So easy question it was. That concept we are going to read in the SOM or sometimes in the material science also. So whatever, so that question has been taken from the strength of material, and from the very basics that question has been taken, and easily you could be able to answer that one if you know little bit. And one more thing, my dear friends, if you talk about brittle, the deformation is very less. So how much deformation? If change in dimension or change in length less than 5%, and body is going to fuel before that, then this is called is brittle. But if change in length is more than 5% and after that it is going to fail, then that type of body is known as what? Brittle. Ductile. So this is, you can say, brittle, right? This is, we can say, ductile. So sometimes in interview they may ask, so simply we can say if change in dimension is less than 5% before the fracture, then it will be called is brittle. But if change in dimension is more than 5% before the fracture, is known as what? Ductile. So basic generic things that you have to know, even they can ask in the interview also. Fine, come to the next question. A machine member is subjected to fluctuating stress. Okay, that means that question has been taken from the machine design. Topic is what? Design against fluctuating load. So the question is that a machine member subjected to fluctuating stress sigma equal to sigma naught cos pi phi t. Okay, the endurance limit of the material is 350 megapascal and the yield strength is how much? 500 megapascal. If the factor of safety used in the design is 3.5, okay, factor of safety is known, how much? 3.5, then the maximum allowable stress sigma naught in the megapascal according to the Soderberg criteria. Okay, so that is the good question, has been asked several times in different exams, and that type of question is also expected that they will ask, because important question is there. First of all, my dear friends, you have to understand what is Soderberg, what is Goodman. Earlier to that I have discussed one question based on Soderberg, Goodman and Gerber parabola, that was just a profile was given and you have to match. Same, so try to remember all these formulas: Soderberg, Goodman, modified Goodman or Gerber. Gerber is not going to be asked, they may ask directly their formula, but question can be asked on the Soderberg, Langer line or modified Goodman. On that you can expect the question. So here question has been asked on the Soderberg. So what is the Soderberg equation, my dear friends? If anyone have remember, try to remember. This is sigma A amplitude of stress upon yield plus of mean upon elastic indolence mean upon yield less than equal to 1 upon n is known as factor of safety. That is Soderberg equation, my dear friends. Try to remember always. Sigma A upon sigma E. Sigma is what? Amplitude stress. Sigma is what? Indolence, which is given in the question. Sigma m is mean stress and sigma y is yield strength, and n is what? Here factor of safety. So my dear friends, read the question properly. If you see in this question, subjected to fluctuating stress. Now the stress in the question is given, this is sigma naught cos of 5 pi t, that is known, fine, okay, and the indolence limit of the material. So sir, sigma E is known, sigma E is known in the question, and the indolence limit of material 350 megapascal. Well, so this is known, and the yield strength, so sigma y is also known. How much? Sigma y is given 500. Well, if the factor of safety, sir, in the question n is also known, sir, 3.5, right? I have to calculate sigma naught, sir. How? So before that, first of all, you have to calculate sigma A and sigma n. Sigma is called amplitude stress. I am coming here, amplitude stress. Sigma A is what, my dear friends? Amplitude stress. How it can be given as? Amplitude stress is always given by, my dear friends, you have to be keep in mind, sigma max minus sigma mean upon 2. Sigma max minus of sigma mean upon 2. If you talk about sigma m, this is called mean stress, and it is given by how much, my dear friends? Sigma max mean, na? So sigma max plus sigma mean upon 2. Maximum plus minimum is given average upon 2, na? maximum plus minimum upon 2. हाँ sir. So sir, in the question how I can calculate sigma max and sigma mean? So in the question sigma is given sigma naught cos of 5 pi t, right? Yes sir. Sir, what will be the maximum value? What we can say the maximum value of sigma max? We can say sir, sigma max will be maximum when cos omega 5 t will be the maximum, right? Sigma naught is constant. If you want sigma maximum, then cos 5 phi t should be what? Maximum. And what is the value of cos maximum? Obviously we can say sir 1. So simply we can get the sigma naught, right? Now if you talk about sigma minimum, what is the sigma minimum sir? Sigma minimum. So sigma minimum will be when cos 5 pi t will be the minimum. What is the minimum value of cos? So sir, minus 1. What is the minimum value? So we can say sir, it is what? Minus 1. So it will be minus sigma naught, right? Okay, yeah, good sir. So put the value. What will be sigma a, my dear friends? We can say sir, sigma naught minus sigma naught by 2. So it is coming out to be sigma naught by 2. Yes sir. And if you talk about what will be sigma m, so sir, sigma max plus sigma mean by 2, so it will be 0. Yes sir, it will be 0. Not put that value in the above equation. We can say sir, equation was sigma a upon sigma e, right, plus sigma m upon sigma y, limiting case 1 upon n. We can say sir, m is 0, so that whole data will be 0. Sigma a is what? Sigma naught by 2, right my dear friends? So sigma naught by 2, our indolence is given how much? I think 350 na. How much it is given? 350. Right, 350 is given there. So 350 is equal to 1 upon n 3.5. Do solve that one my dear friends. Now solve. By solving that, sigma naught is coming out to be how much? This is how much it is. Sorry, it will be, it itself will be sigma naught na. Minimum, this will be sigma naught itself. It will be sigma naught, no need of 2 there. Sigma naught only. By solving that, we will get the 100. So sigma naught is coming how much? 100 megapascal. So correct answer will be the C4 Chennai. My dear friends, in the upcoming exam also we can expect that type of question. Obviously, that different things, they may ask the Langer line, they may ask the good man, or they may ask the modified good man. If you talk about Langer line, modified good man is a basically combination of good man and Langer line. Which one is best? Consider as a modified good man. So be prepared for that. That type of question may be asked that time also. So accordingly you have to be prepared. Fine. That is the next question. A plane stress element in a structural member under the loading has sigma x equal to 4p, sigma y equal to 2p, and tau xy is given root under 3p, where p is more than 0. That means it is a positive quantity. The yield strength of the material is 300 megapascal if the material is designed using the maximum shear stress theory. Which maximum shear stress theory? Then the value of p at the yielding point will be, you have to be calculate that at the yielding point. What will be at the yielding point? So my dear friends, if anyone have remember what is tau max? If you talk about according to maximum shear stress theory, according to maximum shear stress theory, we can say that tau max is equal to sigma yield upon 2, right? Yes sir, that is I know from the maximum shear stress theory. So in the question I have to be calculate the value of p. So first of all sir, in the question yield is given here. Sir, yield strength is given. So sigma yield is given sir, how many? 300 MPa is given sir. Fine. So sir, if anyhow I am able to I will get the tau max. And from tau max, what is tau max my dear friends? Anyone have remember what is tau max? Tau max, if you have remember, so sigma 1 minus sigma 2 upon 2, that is also. So anyhow, if I am capable from there, if sigma 1 sigma 2 I will calculate, from there the work will be gets completed. Now the question is that how you can calculate the sigma 1 and sigma 2. Anyone have remember my dear friends sigma 1 sigma 2 formula? Principal stress, principal strain. So sigma 1 or 2 is given by, we can say sigma x plus sigma y by 2 plus minus root under sigma x minus sigma y by 2 whole square plus tau xy square, right? In the question you have sigma x, sigma y, everything. Sigma 1 equal to, now put the value sigma x. What is the value of sigma x is there, my dear friends? Sigma x equal to 4p, sigma x equal to 4p, so this is 4p. What is the value of sigma y? Sigma y is 2p, right? This value is 2p. Now put this value and make a calculation. If you do calculation, we will get sigma 1 is coming out to be, by solving that, 5p, and sigma 2 is coming out to be p, right? But put that value and by solving we will get that value is coming out to be. So what will be tau max? What will be tau max? Sir, tau max just now you have said is a sigma 1 minus sigma 2 upon 2. So sir, it is coming out to be 5p minus p upon 2. So sir, 2p, right? 2p na? 2p is coming out to be. Tau max you have get the 2p. So we can say from there, sir, here we can write, sir, 2p is equal to 300 upon 2. Can you calculate p? Why not, sir? 300 upon 4. By solving that, how much value is coming out to be? By solving that, we can say how much its value is coming out to be, 75 MPa. So P 75, you can say the B for Bombay is the right answer. So my dear friends, that question has been taken from the theory of failure, and it is expected in all the exam that we can expect the question from the theory of failure. In every exam it is going to be asked. So you know, maximum energy theorem, maximum strain energy, distortion energy, if you talk about Rankine, so all that theory you have to remember, because directly question is going to be asked on that. Sometimes they will ask, okay, shear stress theory is work for which material? Try to remember, it will be for ductile material. Rankine theory is applicable for which material? It will be for the brittle material, right? Distortion energy theory is applicable for which material? So that type of question is also going to be asked. So try to remember that one is also, because you know, as I told you, not all the numericals, not all the difficult question. Yes, some question will be the easy, some question will be straightforward. So you have to be prepared for that also, na? Right. Now come to the next question. Radius of Mohr circle stress element. So yeah, that is a very easy question. Radius of Mohr circle, my dear friends, it is given by tau max, na? Maximum shear stress. Yes, sir. So radius of Mohr circle is what? Maximum shear stress. We can get what? You know, some point. Mohr circle center always lies on the x-axis. You know, Mohr circle center always lie. Center will always lie on which axis? X-axis. Suppose I will ask, is this you know, Mohr circle is possible? We can say no, sir. That Mohr circle is not possible. Is this Mohr circle is possible? Yes, sir. Yes, okay. It could be. It could be, sir. If center is here, it could be. Is this Mohr circle is possible? No, sir. It is not possible, because center of Mohr circle always lies over the x-axis. Here we can see on the y, or we can say on the longitudinal axis where normal stress is existing. In y-axis, you are going to say the shear stress. Now, in a casting process, a horizontal channel through which molten metal flow from pouring basin to reach the mold cavity. This is known as what, my dear friends? You know, casting process. Simply we can see, suppose that is the, you know, cavity, and you are going to pour the molten metal. So this is called what, my dear friends? This is called runner. Here you are going to pour the molten metal, and this is called ingot, and there will be the riser. There could be the riser, and this is your, you know, cavity. Fine. So then in a casting process, horizontal channel. So this runner is a horizontal channel through which molten metal flow from pouring basin to reach the mold cavity. That is pouring basin, and this is the mold cavity. So this will be called is what, my dear friends? This will be called is runner. This will be called is what? Runner. 3D printing technique they are going to be used. What will be that? Just one second. Right, 3D printing technique are selective laser sintering, selective laser melting, electron beam melting, all of the above. 3D printing technique basically consists all that: selective laser sintering, selective laser melting, electron beam melting, all are going to be considered. So correct answer will be D for Delhi, all we can say. So that is the next question, my dear friends. A round wire helical spring, this is the question from the spring, and yeah, we can understand that question has been taken from the machine design, right? One chapter is there, spring, so from there that question has been taken. The question is that a round wire helical spring is loaded by an axial force. The maximum shear stress in the wire cross section will be at outer fiber, inner fiber, center of the cross section, both outer and inner fiber. What will be, my dear friends? Anybody maximum shear stress? In that case, we can say basically torsion. So what is the equation of torsion? T equal to, if you have remember, you can say, sir, T upon J is equal to G theta upon L equal to tau upon R, right? Tau upon R, we can say, na, that is equation of torsion. So from there we can say, sir, tau equal to, can I say, T R by J? Sir. So what is the variation of shear stress with respect to radius? We can say, sir, if radius will be the high, shear stress will be the high. So my dear friend, this is the coil. Here it is a 0, and you go away, radius increases, and at the surface a small r becomes to capital R. So where we can get the maximum shear stress? This is shear stress, na? Where we can get the maximum shear stress? So we can say, sir, outer fiber, where the small r approaches the capital R, right? In that case we will get that one. So correct answer will be what, my dear friends? We can say, sir, A for apple, helical spring, it will be twisted, and due to the twisting equation is given by T by J, G theta by L. G is called modulus rigidity, theta is angle of twist, L length of the shaft, and tau is shear stress, R is the radius. So from there we can get. And no, that is the next question, my dear friends. That means again easy question, but yeah, a little bit looks like lengthy, but actually that is easy question. The question is that a power is transmitted through a spur gear with 20-degree pressure angle mounted at the mid span of shaft, supported on bearing at the ends. Right. The nature of the stress induced in the shaft is: option A, normal stress due to bending only, normal stress due to bending and shear stress due to torsion, normal stress due to bending, axial loading and shear stress due to torsion, normal stress due to axial loading and shear stress due to what? Shear stress due to the torsion. So my dear friends, if you talk about spur gear, right? So in spur gear, normal stress due to bending only. Yes, normal stress responsible for the bending, that right, but not only normal stress is there. Other than normal stress, there is a torsion is also. So A cannot be answered. It is telling only, this only terms makes A wrong. Normal stress due to bending, yes, due to bending normal stress developed, but only not. So A can't be. Normal stress due to bending, shear stress due to torsion. Yes, my dear friends, that is the right answer. Normal stress due to the bending and shear stress due to the torsion is going to be developed. In the previous question also you have seen that shear stress is developed because of the torsion or twisting moment, we can say. Twisting moment is what? Whenever it is at our cross section. Earlier I have told you, my dear friends, how it will twist. This is one of the shaft, let's assume. So if the couple is like that, so this will be twisting, and due to the twisting the shear load is going to be developed over the cross section. But if equal and opposite couple going to be act in the in that, now you can see which axis, longitudinal axis, equal and opposite couple anywhere in the longitudinal axis is going to be act, the result will be the bending, but if the couple equal and opposite couple act over a cross section, that will give the result is what, twisting. So sometimes this thing is also going to be asked in interview, what is difference between the twisting and bending, so you have to be answered accordingly, right. So here we can say, sir, what will be the answer? So B, option C, normal stress due to bending, right. Axial and shear stress, no, axial stress is not coming, in case of Asper gear, my dear friends. Axial stress is not going to be occur in case of Asper gear, right. So it cannot be answer, sir, it can't be answer. Normal stress due to axial, no, axial loading is nothing, so leave that. So correct answer will be what, my dear friends? B for Bombay is the right answer. Fine. So that thing you have to be remember, my dear friends, right. That thing you have to be remember, otherwise you will find difficulties. Yeah, take this question. The question is that a manufacturer has following data regarding a product. Fine. Fixed cost per month is given 80,000 fixed cost, variable cost 350, selling price 500, production capacity 16,000 per month. But if the production is carried out 75% of the rated capacity, then the monthly profit, how much they will get the monthly profit. So that question has been taken from the industrial engineering. One topic is there, you might have remember, inventory, right. Not from the inventory, we can say that question from the break-even analysis. That question has been taken from the break-even analysis. So any manufacturer, see my dear friends, in the question fixed cost is given how much? Fixed cost, which is irrespective of the number of production. So we can say, sir, in the question fixed cost is given 80,000, variable cost per unit, a small v is given, my dear friends, 350 per unit, means okay. Selling price, a small v, a small s is given, this is what, selling price. So a small s is given 500 Rs per unit, right. Production capacity, they have capacity to produce 16,000 unit in a month, but they are only work 75% of a rated capacity, right. You can earn by working whole month, that means 100%, some amount, let's assume x amount, but you are working only for 75% of your total capacity, that means production will be accordingly. So what is the total unit produced? So we can say, sir, total unit produced, if you talk about, so it will be the 0.75 into 1600 when they have production capacity, but working only at the 75% of the rated capacity. So my dear friends, what the unit is coming out to be by solving that 1200. So by solving that we can say 1200 unit. So in a month they are going to produce not 1600 unit, only 1200 unit they are going to be produced, right. Fine. So sir, basic things is there. What will be selling price? See, selling price equal to, we can say, total cost plus a profit, right. Total cost plus a profit, simple thing. If you are going to be sell anything, then yes, you will what, whatever cost is there, and I need some profit also, that's obviously. So what is the, sir, selling cost? So sir, 500 per unit, and how many unit they have produced? 1200 unit. What is total cost, sir? Total cost is fixed cost plus a variable cost plus a profit. So what is the fixed cost, sir? Sir, 500 into 1200, fixed cost is given how much? 80,000. How much it was? Fixed cost was 80,000. So sir, 80,000, right, plus variable cost. How many unit? 1200 into what is the variable cost per unit? What is the variable cost per unit? 350, right. So 350 plus P. Now can you not calculate P from there? Can you not calculate P? Tell me. Okay, can you calculate? If you can, tell me the answer. If yes, then yes, give the answer. By solving that, I am going to get the profit is coming out to be how much? 1 lakh. Profit they people will get 1 lakh. So the answer will be what, my dear friends? Answer will be the A for apple, 1 lakh is the right answer. Fine. So yeah, it was also easy question. Next question again has been taken from the industrial engineering. The question is that for a PERT activity, the optimistic time is 6 minutes, the most likely occult time is 9 minutes, and pessimistic time is 16 minutes. The expected time of the activity is, you have to be calculate TE in second, in second. Okay. So what is the optimistic time? This is called TO. What is the most likely occur time? So we can say 4 TM plus of TP whole upon 6, that is. So T naught is optimistic times. Optimistic time is that time, my dear friends, if everything is run according to plan. If you start any business, if you do anything, so you made plan, and if everything is running according to your plan, so that is called optimistic time. So in the question it is given 6 minutes. What is pessimistic times? Pessimistic time is that time that everything is goes against your against your plan. Everything is goes against your plan. Then this is called pessimistic time, and this is given here 16 minutes, and most likely occult time 9 minutes. So now solve that one. So we can say 6 plus 9 is to 4 plus 16 upon 6. By solving that, how much it is coming out to be, my dear friends? By solving that, it is coming out to be 9.66 minutes. 9.66 minutes. But in the question, the option in the second, my dear friends, if you go through the option, you will find it is given in the second, right? So convert in the minute, convert in the second. So just multiply it by 60. So how much it is coming out to be? I think 580. You can check out it. Approximately it will come out to 580. It is coming out to be 580 second. Fine. Good. Coming to the next question. This is the next question. Has been taken from the machine, you can say tome. The question is that a cantilever beam of cross section area A, moment of inertia I, and length L, having natural frequency omega 1, finds up. If the beam is accidentally broken into two halves, the natural frequency of the remaining cantilever beam is omega 2 will be such that option A increases, decreases, both have same, or cannot be obtained from the given data. Now first of all, my dear friends, you have a cantilever beam like that. This is your cantilever beam, length is L, small l, capital L, okay, small l is there, and natural frequency is given omega 1. Accidentally they are going to breaken out from the center, right? If accidentally broken into two half, then natural frequency. Now the first question is that what is the value of natural frequency, my dear friends? Try to remember, natural frequency is omega is given by beta 1 square upon L square, or you can say beta upon L whole square, plus of root under EI upon rho A. That is the formula you have to remember, given by. So in this question we can see that every data is remains constant, only what is going to be changed? Only length is going to be changed. So from that, can you make one conclusion? Sir, omega is proportional to 1 upon L square. Why not, sir? Yes, sir. If rest thing is constant, I can make a conclusion like that, right? You can make a conclusion like that. W is proportional to 1 upon L square. Okay, 1 upon L square. Now my dear friends, from there we can say, sir, omega L square equal to constant. So I can say omega 1 L1 square is equal to omega 2 L2 square. So L1 you can say, sir, L2 equal to L1 upon 2, right? So from there what is coming out to be omega 1 L1 square is equal to omega 2, instead of L1 upon 2 I can write this is whole square. So it is coming out to be omega 2. What will be omega 2 from there? We can say So omega 1 L1 square into what 4 na 4 equal to omega 2 L1 square. L1 square L1 square going to be cancelled out. So omega 2 equal to 4 times of omega 2 equal to 4 times of omega 1. That means natural frequency increases or decreases, my dear friends? Tell me. So we can say, sir, omega 2 is more than omega 1, na sir? Omega 2 is more than omega 1. So what answer we will get? Omega 2 is more than omega 1. That means it will increases. The correct answer is what, my dear friends? A for apple is the right answer. A for apple is the right answer. So you have to be proceed in that way and you will get the answer. But try to remember that data, at least that L, how it is going to be changed out. If that type of question is coming now, my dear friends, always make all the quantity constant, only those quantity will be variable which is going to be changed. Rest you have to be assume constant, and we can move very easily to solve that type of question. Now that is the again question has been taken from the machine design. What is the question? Question is, if the load acting on the ball bearing increase 2 times, its life will. The option you have, what will be their life? That question has been taken from the machine design. One topic is their bearing, right? One topic is there, what, my defense? Bearing. So actually that question has been taken from the bearing. So you know how you can calculate the life in case of bearing? If you have remember, then life is given by, my dear friends, like that. Life is given by C upon pk power k. K is equal to 3 for ball bearing. For ball bearing, or k is equal to 10 upon 3 in case of roller bearing. In case of what? Roller bearing, right? So in the question, ball is clear cut mentioned. C is called basic dynamic capacity, which is constant for a given bearing. If bearing is not going to be changed, C will not going to be changed, right? It will be constant for a given bearing. Dynamic basic load carrying, you can say capacity, dynamic. So, or catalog load impact, sometimes you are used to say. So my dear friends, we can say, so from there can I say L is equal to C upon p k power 3, because in the question, so sir, C is constant, sir. So can I say L is proportional to 1 upon p k power 3. So can I say, sir, can I say ki L p k power 3 equal to constant. So sir, can I say what? L1 p1 k power 3 is equal to L2 p2 k power 3. So in the question, what is the condition? Ball bearing, if the load on the ball bearing increase by 2 times, increase by 2 times. So we can say, sir, here P2 is equal to 2 of P1, right? So L1 P1 ke power Q is equal to L2 2 ki P1 ke power Q. So it is coming out to be L2 what 8 P1 ke power Q. So sir, this is given by, so L1 equal to 8 L2, or in fact I can say, sir, L1 upon 8 equal to L2. So what will be the new life? So from there we can say, sir, L2 equal to L1 into 1 upon 8. That means initially whatever life was there, now their life is decreases by 8 times. And that is a very frequently question has been asked in different exams. Very frequently has been asked. Very frequently means very frequently. If you go through, you know, Q by Q in all the exam, that type of question has been asked. Still a student is not going to remember that equation. I don't know why. No, you have to remember that one. So we can say life is decreased by 8 times. So reduced by 8 times. C for Chennai is the right answer. So now let us take that question. And the question is that here we can see an old clutch is to be transmit. What question? Question is an old clutch is to transmit a torque of 100 Newton meter. The inner and outer dia of the clutch plate 100 and 200 mm respectively. The force required for engagement is and you have to assume mu is equal to 1 upon 3 with uniform wear theory. Suppose in the question if it is not given that you have to be solved by using uniform wear theory, by default you can take UWT, because whenever clutch plate is old now, uniform pressure cannot exist everywhere. Uniform pressure you cannot obtain. Uniform pressure only you can obtain when the clutch plate is new. So if in the question if nothing is mentioned, by default we can assume uniform wear theory. Like that question nothing is, but okay, in this question it is mentioned. But suppose if any time is question going to ask and nothing is going to mention in the question, that which theory you have to apply, uniform pressure theory or uniform wear theory. In such case by default we can use the uniform wear theory. So my dear friends, sir, force required for the engagement. So sir, I have to be calculate W. So what is torque? If you have remember, torque is mu W R effective. Here W is what? Load. Mu is coefficient of friction. R effective is what? In case of UWT, uniform. In case of uniform wear theory, it is R naught plus Ri upon 2. That is only mu W R effective, R naught plus Ri upon 2. So now put the value, my dear friends. In the question, torque is given. So here we can say, sir, W is equal to, simply I can say what will be equal to W equal to, simply we can say, sir, W is equal to, we can say T upon mu into R effective, or we can say R naught plus Ri upon 2. In the question, torque is given how much? Torque is given 4. Torque is given 100 upon mu 1 upon 3. Here D naught, so simply we can say D naught minus D naught di. This just put the value. I think this is 0.2 and 0.1. Okay, whole upon 4, because diameter is given na, so upon whole upon is what? 4. So by solving that we will get the value is coming out to be 4000 Newton, or we can say 4 kilo Newton. Getting na? Diameter is given na, so you can write it na like that. So D naught plus di upon 4 also na. This can be written like that also. Rho plus Ri upon 2 equal to D naught plus di upon 4. Simply I can write, right? So by that way we can get the answer. So I don't think that was a difficult question. Easily we can do. Now my dear friends, that is the next question on your screen. The question is that the elastic strain energy stored in a rectangular cantilever beam due to bending moment M applied at end given by sigma max is maximum bending stress, V is the volume, and E is the Young's modulus of elasticity. So you have to calculate the strain energy, my dear friends, right? Strain energy. So what is strain energy? Strain energy basically energy absorbed within the body when it is going to be deformed. Yeah, it is two types. One you can say resilience, one is you can say toughness. So the question is that here you have to be calculate the, simply we can say the bend, strain energy, right? So what is the strain energy, my dear friends? If you have remember, half P into theta in case of axial load. In case of axial load, half m square L upon EI. In case of pure bending, in case of bending, in case of torsion, half T into theta. Half T into theta, if you have remember, T into theta. So that fall out also. In the question, you here M is applied now, so there will be bending. So I will ask what will be the strain energy? What will be the strain energy? We can say, sir, half m square L upon 2 each EI will be. But in the question we can say the given things in not and in that form. The given answer is not in that form. So first what you have to do, you have to be convert that thing in the form of, in the given option form. So simply we can say, my dear friends, how I can do that? So sir, use the bending equation. Do you know bending equation, if you have remember? Yes sir. What is the bending equation? What is the bending equation, my dear friends? Simply we can say, sir, sigma B is equal to, can I write, M H by 2 into B H Q upon 12. Can I say? Yes sir. So this will be the maximum bending moment. Maximum bending stress is developed because of M. Now solve that one. By solving that, sigma B is coming out to be 6m upon BHQ. 6m upon BHQ. So this is the sigma bending stress. 6m upon BHQ. This is the bending stress is coming. Maximum bending stress. Now if I will ask what will be M? What will be M, my dear friends? So we can say, sir, M will be sigma B BHQ upon 6. Now put that value in strain energy. If you have remember, strain energy is what? Half m square L upon EI. Now put that value, there. Now put that value here, By putting that, if you are going to put that value, so from there we can get the strain energy is coming out to be sigma max square into B HL upon 6E. So BHL is what? Volume, na? This is what? Volume. So we can say strain energy is equal to what? It is coming out to be sigma max square into length, which height is volume, whole upon 6E. So that will be your answer. Now go through the option. If you are going to sigma x square B upon 6E, sigma square B upon 6E, Chennai is the right answer. Okay, directly we can do in that form. So strain energy is important for ISRO. So try to do it in the very detailed manner. Now that is the next question. Here we can say, see, a stainless steel rod of diameter is given 12 mm, length is given 2.5 meter, is kept on a frictionless surface and heated from 300 Kelvin to 400 Kelvin. What is the thermal stress on the rod, coefficient of linear expansion, and that all R is given here. So now what a student is going to make mistake, they will think, sir, you know what, stress is given by thermal stress is given by E alpha delta T, right? And a student will do, they will put the value of E is given or not given? Yeah, given. 2 1 0 10 to the power 9. Alpha is also given or not? Yes, 10 to the power minus 5, and delta T is also given 100. But my dear friend, that approach is wrong. And by solving that we will get some answer. I don't know, but yeah, by solving that we will get some option, either A, C or B. Anyone will get the option, and a student is going to be tick that. But it is a wrong answer, my dear friends. Here now question is that, sir, what will be stress? My dear friends, here the correct answer is 0. Now we can ask, sir, why 0, sir? How you are going to be say 0? My dear friends, in the class I always used to say, like here this term frictionless surface basically indicate that it is free to expand, like that. This is the thing now, and if I am going to heat them, so it is free to expand. And in case of free to expand, is there any stress will develop? No. Stress basically comes because of internal resistance force. So if you are going to heat them, no any internal resistance force is develop. If no any resistance force is develop, no stress will develop. So this frictionless surface gives indication that this is the something regarding the free free expansion, thermal stress with free expansion. So value is coming out to be 0, my dear friends. So that was the key word here in that question. My dear friends, you can say, sir, how we can say? My dear friends, suppose if you are going to be heat them, and is there any restriction like that? If the restriction is like that, is there friction will come? Yes, sir, friction will come at the interface of two surface. The friction will come, sir. If I am going to heat them, then at the interface of two surface, friction will come. But the question is telling it is a frictionless surface. That means nothing is there. It is free to move. That's why, my dear friends, it is the case of free expansion, and your answer will be D for Delhi. 0 megapascal is the right answer. That's why I used to say you have to be think like a scientist if you want to be get selected in the what, my dear friends? ISRO, Indian Space Research Organization. Fine, that is the next question. What kind of deformation that occurs in shape memory LY? So my dear friends, if you talk about shape memory LY, like neutron undergoes thermoelastic transformation when deformed and reheat. What thermoelastic if you talk about? So upon heating, the martensite transform back to austenite phase and recovering its original. So thermoelastic and thermoplastic both options are there, but what will be the correct answer, my dear friends? In case of shape of memory LY, we are going to use thermoelastic, means we can change their shape by heating. They can be softened, by cooling they can make hardened, and that process we can repeat a various number of times. So this is what thermoelastic, not the thermoplastic, also known as thermosetting we can say. Now that is the next question. Question is that a face milling operation, which type of operation? Face milling operation, right, is carried out with a 100 mm diameter milling cutter having 4 teeth and a spindle speed of 300 rpm. If the feed per tooth is 0.125 mm, what is the table feed in mm per minute? You have to be calculate table feed. So my dear friends, v of f, feed velocity, is always given by f z into n. F z into n. F z is here, F z 0.125 mm per tooth. F z. If you talk about z, this is given 4, and if you talk about n, so this is given 300 rpm, right? This is what 300 rpm. So by put this value in all that, and by solving that, we will get the value how much it is coming out to be. That formula you have to be keep in mind. I think it is coming out to be, by putting all that value, by solving that, 150 mm per minute. 150 mm per minute is coming out to be 150 minute per minute. So mm per minute. So what option could be, my dear friends? Chennai is the right answer. C for Chennai is the right answer. Next, which of the correct sequence of machining operation to be performed to finish through a hole of a large diameter? Drilling, ramming, boring, drilling, boring, ramming, boring, drilling, ramming, boring, ramming, or drilling. You know, my dear friends, whenever you have to produce the hole, first approach you have to use the drill. In your home also, whenever you have to use the hanger, you are going to put the hanger. First of all, you need to drill. One drill is happening. After that, to enlarge the whole dia, in turn you can say to enlargement of the whole dia, you are going to perform the boring operation. Boring is sometimes called internal, internal turning, you can also say. So it is going to be enlarge the whole dia. So first of all, you have to do the drilling, right? After drilling, you have to do the boring, and after boring, if you want to get more precise result up to the 3 decimal, then you have to use the ramming. So what the sequence you have to be follow? First of all, drilling, boring, and ramming. So B for Bombay is the right answer. Drilling, boring, and ramming. That is the next question. In abrasive jet machining process, the mechanism of material removal takes place due to electrochemical, ionic, mechanical impact, melting, and evaporation. In abrasive jet machining process, the main mechanism of material removal takes place. This is because of what, my dear friends? Mechanical impact. This appears because of, you can say, mechanical impact, right? Okay, good. Come to next question. That is the next question. A point load applied at shear center of beam induces zero shear force, zero bending, pure twisting, or pure bending. So what will be the answer, my dear friends? When point load is applied exactly at the shear center of a beam, the beam undergoes transverse shear force and bending moment, but no torsion. Therefore, beam experience pure bending under this condition. Whenever point applied at the shear center, a point load is applied at the shear center, that gives the pure bending. So the correct answer will be B for Bombay. A point load applied on the shear center, the beam induce only bending. Coming to the next question. So that is the next question, my dear friends. A body subjected to biaxial state of stress as shown in the figure below, the magnitude of normal and shear stress acting on 45-degree plane in ampere, that option. My dear friends, that is the question has been asked in GATE, and same question has been copy paste in the ISRO also. I think little bit data I change, everything is fine. That question has been asked in civil engineering GATE, civil engineering SOM paper it was question. So everything is same, only data is change here. So sometimes PYQ question will help you in the exam. So what you have to calculate the bending and normal shear stress acting at a 45-degree plane So my dear friends, you know, like that na. So there could be infinite number of planes, like suppose that, so this could be one plane, right? That can be one plane or not, like that. There, this is the one of the plane, let's assume this is one of the plane, this is at the 45 degree, and you are going to apply the load there. So what will be the effect of that load on that one, the plane? And you know, as you are going to be change the theta, we will get the different planes. As you are going to be change the theta change, so you are getting the different planes. So the plane which is at the 45 degree, you have to be calculate the shear stress and normal stress, the magnitude of normal and shear stress acting 45 degree plane in the megapascal. So here we can say 60, and yeah, it is a bidirectional load, sigma y, even tau is also given there in that. So my dear friends, first of all, you know how the sigma n is given as normal stress on oblique plane. Normal stress on oblique plane is given by sigma x plus sigma y by 2 plus of sigma x minus sigma y by 2 sin 2 theta plus of tau xy cos 2 theta. If you have to calculate the right tau xy, if you have to calculate the shear stress on that oblique plane, so it is given by minus sigma x minus sigma y by 2 cos 2 theta sin 2 theta will be plus of tau xy cos of 2 theta. That is the formula you have to be just keep in mind. Now put the value of sigma x, sigma 1. If you have to get the sigma and the value I am going to be write, it is coming out to be by putting that value 10 plus 50 cos of 90 plus 30 sin of 90. By solving that we will get the 40, and tau by solving the same we will get the how much, 50. So 50 MPa and 40 MPa. So the correct answer will be 40 and 50. Simply will get. So my dear friend, that is important formulas going to ask in different exams. You know, as you are going to apply the load there and there, that there will be different defect effect at that plane. As you change the theta, we will get the different value. And currently we can say at the 45 degree plane we can get the maximum shear plane. Now, okay. Now come to the next one. That is the next question from the bending. That question has been from the deflection, strength of material. Question is that determine equation of the elastic curve. Elastic curve means they talk about the deflection, my dear friends. So whenever you talk about now elastic curve means talk about, they are going to be talk about deflection of the cantilever beam of uniform cross section shown in the figure. Due to applied bending moment M1, consider Young's modulus E and moment of inertia is what, I. So much simply we can say, sir, this is the cantilever beam, and 1 m constant bending moment, constant couple has been applied. So in that case, my dear friends, slope, if you know, you will use the EI d square y upon dx square is equal to m. Now by solving that equation, de-integrate both the side, and by doing that I will get the value I, y, and it is coming out to be mx square upon 2 EI. Mx square upon 2 EI is coming out to be mx square upon 2 EI. So what could be answer, my dear friends? Chennai is the right answer. After the deflection, the body will be something like that. No, it will be something like that, and we'll get that value. So try to remember some standard formula which will help you in the exam. Now, fine. Now the preferred choice of steel material for cryogenic application is ferrite, austenite, martensite, or of the above. Preferred steel material for cryogenic application is austenitic steel. Why? Because austenitic steel maintain excellent toughness, ductility and strength, at extremely low temperature. If you talk about austenite, they can maintain their ductility, toughness, right, ductility, toughness, strength even at a very low temperature. They can maintain that one. So that is the one of the good property regarding with the austenite. That's why in the cryogenic you are going to use the austenite. But if you talk about martensite, so martensite, what they do, martensite basically becomes very brittle. It becomes very brittle at a low temperature and it can sudden fail. That's why, my dear friends, in the cryogenic, even at the helium which is in the liquid state, I think at a temperature something minus 269 degrees Celsius, minus 269, approximate we can say 4 Kelvin. In that I am going to use the austenitic steel. So the correct answer will be austenite. Why not martensite? At that temperature it becomes very brittle, like a glass, just do that, glass is going to be broken out. That's why, my dear friends, you have to be just keep in mind it will be the austenite. Now that is the next question. Which of the following is not a casting defect? Which of the following is not a casting defect? Expander, blowhole, cold shot or hot tears? Which of not a casting? Not. So my dear friends, expander is a welding defect. Expander is what, my dear friends? This is a welding defect. So it will not be a casting defect. So answer will be the expander. What is blowholes? Blowholes is the casting defect because of trapped gases. Now if you talk about cold shot, what is cold shot? What is hot tears? You all have to be remember what is cold shot. Anybody can tell me? Comment. What is hot tears? When hot tears is which type of effect and cold shot is which type of defect? You have to be comment. Next, which of the following improve weldability of steel? Which of the following improve weldability of the steel? Right. So you talk about which of the following. Option A, low carbon content and poor affinity to oxygen, high carbon content and poor affinity to oxygen, low carbon content and good affinity to oxygen. Now see, my difference, I am coming. If you can say improve the weldability, if anything which is high affinity to the oxygen, anything is there, just think, if they have high affinity to the oxygen, they will make oxide and it will make a brittle the surface. If the oxide is coming, the surface will be very brittle. So first thing that you can know, sir, affinity of oxygen should be less, sir, so that no oxidation to takes place, no oxide will form there. That's why we can say, sir, good affinity is bad thing, sir. So option C and D cannot be, sir. There should not be good affinity. So sir, either should be option A or option B. Now tell me how, what we can say. Now my dear friends, if you talk about low carbon content and high carbon content, if you talk about low carbon content, so low carbon content improve weldability because it reduces the hardness, brittleness of weld and heat affected zone. It reduces because in the low carbon content percentage of carbon is less. So if the percentage of carbon is less, it will be less brittle. So so it will support. They are not making the joint to much more brittle. But if you talk about high carbon content, they will make a joint brittle. Even it becomes much more hard. That's why, my dear friends, low carbon content and poor affinity of oxygen will be the right answer. So correct answer is what? A for apple is the right answer. Right, not B. C and D, it can't be because high affinity is given there. Fine. So think like that. Now see, that is the next question on your screen, my dear friends. Okay, the question is that what is the true respect of self-locking screw jack with a square thread? Which type of thread is there? A square thread. So what we can say the answer, my dear friends? Here we can see the friction angle is more than helix angle of the thread. For self-locking condition is there, no, screw jack with a squared thread, right? The friction angle is more than helix angle. Yeah, that is right. Friction angle will be more than helix angle. The efficiency of a screw jack should not be more than 50%. That is also right. So statement 1 and 2 both are right, my dear friends. That is the topic has been taken from the machine design. One is a screw. From that question has been taken. Sorry. So we can say Chennai is the right answer. C for Chennai is the right answer. Both are the correct. Now, the commonly used flux for the brazing. In the class I used to say, my dear friends, B for brazing, B for borax. So always try to keep in mind, if you talk about commonly flux used in the brazing is borax. Right, that is the way you could be remember. B for brazing, B for borax is going to be used. Basically sodium tetraborate is that widely employed in the brazing operation because it effectively dissolve metal oxide and provide a protective layers over the molten joint, right? So B for borax, B for brazing, you have to be just remember. Now my dear friends, that is the question, okay, and that question has been taken from the CPM PERT. I am going to be little bit little bit zoom out that one, so that I will do here question itself. Okay, see, you have to be calculate the maximum time. See, that is a, let's assume point 1. From there A is coming. A, how many days it takes? 6 days. Now point that is node 2, and now from A, B and C is going out to B. So this is let's assume 3, and B is there. How many days? It takes 5 days, and from there let's assume this is 4 and this is C, activity is C, and this is taken 8 days to get completed, right? And after D, immediate presence B, from B, D is coming out. So let's assume this is D. How many time it take? 11 days. Let's assume this is 5, and you have to see here D and D is going to be matched. D and D, from the D and D F will goes out. So from C, E, so E you have to meet there. This is E, and how much it takes? 6 days, and after that F is going to be F, and let's assume 6, and how many days? 7 days. So you have to be find critical path or minimum time in which we can say the project is completed. See my dear friends, 6, 5, 11, 11, 11, 27 plus 7, 29. If you any other path, A 6 plus 8, 6 plus 6, 12 plus 8, 20 plus 7, 27. If you follow that part 27, that part 29. So correct answer will be G for Chennai is the right answer, 29. In the classroom I used to say how to make a that diagram will help you. Now that is the next question, my dear friends. Can you tell me the answer? What is this? The property of a material that represent maximum amount of strain energy that can absorb before the fracture. You talk about the before of fracture. So if you talk about fracture, obviously it will be toughness, so it will be modulus of toughness. So my dear friends, in that way, that was the part that I have completed. Now Beneath sir will come and they will deal you with next some more question. Whatever question is left will be solved by the Beneath sir. So my dear friends, what the conclusion we can make? If you see overall 70 to 75% question is tougher, calculative is also there. 10 to 15% question we can see easier, that in which you just see the option, like that question, just see the option and you are capable to tick the option. And few questions are moderate, so like that question, but yeah, 70% was numerical calculative. So accordingly you have to be prepared for the exam if you want to be get selected. As I first in the very starting of the session I have told you, you have to be think like a scientist. If any problem is coming, you have to be think like a scientist if you want to get selected in the ISRO. So that is the main thing, my dear friends. And YourPedia and ECP team have running a dedicated batch only for the keeping in mind of the ISRO. So you can join that. This will help you a lot and will play a catalyst role in your selection. It will make you faster. So our team is here, they will help you out here. and now Bineet sir will come and take the rest question. Okay, so but one thing, keep practice, take different types of question, try to think once question is getting, that will improve your question solving ability. Okay my dear friends, thank you. Bineet sir, welcome.
Hello everyone. So first half of the paper has been solved by the Rajiv sir. Okay, so now I'm going to proceed with the further question, and we are left with the 30 questions of the technical right now. So here you can see the question number 51. A slider is moving outward on a road QR with a velocity of 3 meter per second and corresponding the acceleration of 9 meter per second square. Okay, so in this case what is given to us, we have been provided with a road on which some slider is there which is moving with some velocity. Correspondingly it is having some linear acceleration also. Okay, and correspondingly the road has an angular velocity of a 7 radian per second counterclockwise about the point O, and it is also possessing some amount of the angular acceleration also. So what do we want to find out? We want to find out the value of the absolute acceleration of the slider in this case here. Okay, so first of all, if you have a little bit understanding of the coriolysis acceleration, so basically in this case we have a rotating link, okay, on which some slider is sliding. So we can say in this question the slider is also possessing some coriolysis acceleration. Okay, so if I just create a free body diagram of a slider, you are going to observe like here we have a simple slider. Okay, in this case the velocity is equal to 3 meter per second, and corresponding the linear acceleration, that is representing by AL, is equal to 9 meter per second square. So now you should be aware of that whenever a link is rotating, there is a inward radial acceleration acting over a body here. So I can say there will be a radial acceleration here, and its magnitude is going to be equal to r omega square. Okay, correspondingly it is also possessing the angular acceleration. So due to the angular acceleration, the slider is going to have some tangential acceleration also. So now in this case the angular acceleration, it is having a direction in the clockwise direction here. So I can say the tangential acceleration is going to be at here in this case, and its magnitude is going to be equal to r of alpha. Okay, and correspondingly if you just see here we are going to have a coriolysis acceleration also, and but now the question is, how do we find out the direction of the coriolysis acceleration? So first of all, just see the direction of the velocity vector. Okay, and just rotate the velocity vector by 90 degree in the same sense of the angular velocity. So if you just see, the angular velocity is having a direction of anti-clockwise, so we are going to rotate the velocity vector by 90 degree in the anti-clockwise direction itself. So I can say the coriolysis acceleration is going to be at upward here, and its magnitude is going to be equal to 2v omega. Okay, so therefore you can see the net acceleration is going to be equal to the sum of all of these accelerations here. So here I can say the total acceleration can be simply calculated by the net acceleration which is acting along the horizontal direction, that is AR minus AL here ka whole of square, plus we have a coriolysis acceleration as well as the tangential acceleration in the vertically upward direction. So I can write AC minus AT square here. Okay, you can also assume the AT as a positive and AC as a negative depending upon your sign conventions here. Okay, here I am assuming the left side is representing the positive sign and the upward sign is representing the positive sign here. Now just calculate each and every value and just put the value here. So first of all, the radial acceleration is going to be equal to, okay, so now in this question r is given to us 1, omega is given to us 7 radian per second here. Okay, so I can write the radial acceleration is going to be equal to 49 meter per second square. Correspondingly, if you just see, the linear acceleration is given to us in the question as, it is given to us as 9 meter per second square. Along with that, we are provided with the coriolysis acceleration. Coriolysis acceleration is 2v omega. So v is given to us 3 meter per second, and correspondingly the omega is given to us 7. So I can say it will be equal to 42 meter per second square. Okay, along with that we have a tangential acceleration also, which is having a magnitude of r into alpha. So here you can see the r is given to you as 1 and alpha is given to you as 12 here. So it will be equal to 12 meter per second square. So if I calculate the value of the total acceleration, the total acceleration is going to be equal to radial acceleration, that is 49, linear acceleration, that is 9, plus coriolysis acceleration, that is 42, and tangential acceleration as 12 meter per second square. So if I solve this entire problem, you are going to get the value of the total acceleration as 50 meter per second square. Okay, so that's the solution of the first question here. So I can say the option number B is going to be the correct answer of this particular question here. Okay, so that's a very simple case. Although the numerical the calculation has to be done here, but the question is very simple. The next question, the type of gear used to transmit the rotary motion between the non-parallel and non-intersecting shaft here. Okay, so that's a very simple theoretical based question. So in this case, the worm and worm wheel gear are basically used to transmit the motion between the non-parallels as well as the non-intersection shaft here. Okay, so option number D will be the correct one. Next question. In this case, the configuration of a planar 4-bar mechanism with a frictionless joint is shown in the figure. The length of the link L1, one is 40 millimeter here, 2 is 15 millimeter here, correspondingly L3 is 35 millimeter here, and L4 is 30 millimeter here. Okay, what do we want to find out? We want to find out the value of the mechanical advantage, that is output torque divided by input torque here. Okay, we have to calculate the value of the mechanical advantage, output torque by input torque. So as we know that in a mechanism, the input power is going to be equal to the output power. So I can say input torque multiplied by input omega is going to be equal to output torque multiplied by output omega. So I can simply write the mechanical advantage is going to be equal to output torque by input torque equal to the angular velocity of the input link divided by angular velocity of the output link. So in that case, basically we have to calculate the ratios of the angular velocities here in this case. Okay, so now in order to calculate that, first of all we have to check that whether the Grashof law is satisfied here or not. And what is the Grashof law? Grashof law simply states that the S plus L has to be equal to or less than P plus Q here, where S is representing the length of the shortest link, L is representing the length of the largest link here. Okay, so in that case you can see S is 15, L is 40, which will be come out to be as 55 here, and correspondingly P plus Q is equal to 30 plus 35, that is 65. So you can directly see here 55 is less than 65, so I can say the Grashof law is satisfied here. Okay, Grashof law is satisfied. Now the next part is in this case the shortest link is fixed to the adjacent to the the shortest link is fixed adjacent to the fixed link here. So I can say this mechanism is basically a inversion of crank rocker mechanism here. Okay, so here we have a crank rocker mechanism in which the shortest link is having a full rotation, whereas the rocker is having the output link is having a oscillatory motion here. Okay, so it is a crank rocker mechanism. Now the next thing is okay, so now just see, in this case we want to calculate the value of the mechanical advantage. Okay, so if you observe the analysis mechanism very carefully, you are going to find that this position is basically representing the extreme position of the output link here. Why? Because if you just see, this is simply a right angle triangle, and as soon as the link as soon as the crank rotates, correspondingly the output link will start moving toward the inner side here. Okay, so I can say it will be a toggle position here, extreme position. Generally, let us say it is gamma here. So generally, when the value of gamma is equal to 0 and when the value of gamma is equal to 180 degree in the crank rocker mechanism, we observe that the output link is at the position of toggle position here. Okay, so whenever the output link is at the toggle position, so I can say the output angular velocity, the angular velocity of the output link or the final link is going to be 0 only. Okay, so therefore I can say in this case mechanical advantage, which is equal to the output torque by input torque, is equal to in angular velocity of the input link divided by angular velocity of the output link. It will become infinity here, because the output link is having a zero angular velocity at the toggle position here. Okay, so in this case the option number C will be the correct answer here. Okay, so that's again a very simple question. Now the next part, a mass m is attached to the two identical springs having the stiffness k as shown in the figure here. What will be the natural frequency of the vibrating system? So that's a very simple question. Here you can see, if I displace the mass by certain distance, the both of these springs are going to have a same deformation. So I can say the spring can be considered as they are arranged in the parallel combination. So therefore correspondingly the equivalent stiffness is going to be equal to 2k, sum of these two stiffnesses here simply, and correspondingly the natural frequency will become equal to k by m. Okay, so I can write under root of 2k by m, and correspondingly the natural frequency in the linear frequency will become equal to 1 by 2 pi multiplied by 2k by m here. So in this case the option number B will be the correct one here. Okay, so again that's a very simple case here. Now the next part is, a damped spring mass system is forced to oscillate at time t equal to 0 by the application of an impulsive force. Which of the followings are the true here? If the damping ratio is between 0 and 1, the system will show no oscillation. Okay, so first of all just understand what is the meaning of damping ratio. Damping ratio is representing by zeta here. Okay, damping ratio is the zeta here, and correspondingly we know if the damping ratio is there, or if the damping coefficient is provided here, so that simply means there is some friction present inside the vibrating system here. Okay, and the corresponding governing differential equation in this case is written as x double dot plus 2 zeta omega n x dot plus omega n square x equal to 0. Okay, so now on the basis of the values of the zeta, there are corresponding three systems here. We have a underdamped system, we have a critical damped system, we have a overdamped system. So when the value of zeta is equal to 1, we have a critically damped. When it is less than 1, we have a underdamped, and when it is more than 1, we have a overdamped here. Okay, and out of these three systems, only the underdamped system is considered as the vibrating system here, because it is the mathematical solution of this particular case is having the sign term which is showing the oscillations here. Okay, I can say the moment of the body about the to and mean position here. So correspondingly I can write, if the damping ratio is between the 0 and 1, the system is going to show oscillations. Okay, but after a certain period of time it will go 0 here, because due to the damping it is getting 0. So statement number A is the wrong one here. It is wrong one. If the damping ratio is between 0 and 1, the system will eventually come to rest. That is a correct statement. The thing which I have just mentioned you right now. If the damping ratio is less than 0, the system will eventually come to rest. The damping ratio can never have a value less than 0. Here. Okay, so statement number C is also incorrect here. The system will always oscillate. That is also a wrong one, because as soon as the zeta will become equal to 1 and more than 1, the corresponding there will be no vibration in this system here. If I simply show the graphical representation of the displacement with respect to time here, you are going to observe this red color is representing the oscillations here. Okay, this is a underdamped system here in this case, and correspondingly if I just show the critically damped system, the critically damped system is going to be shown like this one here. Okay, so you can see from here the moment of the displacement has been studied, and eventually it is coming to its mean position without any oscillations here. Okay, and correspondingly if I just show you the overdamped system, it will going to be shown like this one here. Okay, just remember that part. And along with that, here we have an amplitude. So this is the amplitude x1, this is the amplitude x2, this is the amplitude x3 here, and so on. So you should know that the ratio of all of these amplitude x1 by x2, x2 by x3, x3 by x4 is going to be remain same. It is going to be remain same, and it is having a value equal to exponential to the power zeta omega and td here. Okay, where td is representing the damped time period of the damped vibration, which is having a formula of 2 pi by omega d, which can further be written as 2 pi by omega n multiplied by under root of 1 minus zeta square. Okay, and correspondingly the time taken to complete one damped cycle is equal to the damped time period. Okay, the time is going to be remain same. Just remember that part. So in this case, the option number B will be the correct answers here. Okay. Now the next part, question number 56. The velocity field of a certain two-dimensional flow is given by kxi cap minus yj cap. It is actually kxi cap minus yj cap here. Okay, where k is equal to 2 per second if the fluid density is 100 kilogram per meter cube, 100 kilogram per meter cube, and correspondingly the pressure at the origin is 10 kilopascal. Then what will be the pressure at point number 3? Okay, so this, see here, the pressure at the origin is given to you, and you have to calculate the pressure at the some point 3,3, and correspondingly we can find out the values of the velocity with this particular equation at 3,3 as well as the 0,0 here. Okay, so I can simply use the Bernoulli equation to calculate the values of the pressure at the point number 3,3 here. Okay, so let us calculate first the velocity values here. So in this case, first of all, just see, u is going to be equal to kx here, v is going to be equal to ky here, minus ky here. Okay, the velocity component along the x direction and the velocity component along the y direction. So I can write the total magnitude of the velocity will become equal to u square plus v square, which can further be written as k x square plus y square. So I can write the velocity at origin is going to be equal to 2 0 square plus 0 square, that will be equal to 0, and the velocity at the at 3,3 will become 2 3 square plus 3 square, that will become equal to 9 plus 9 18 3 6 root 2 here. This will become the velocity. So now just by applying the Bernoulli equation between the point 1 and point 2, applying the Bernoulli equation, so there is no information given regarding the potential energy, so I am assuming the potential energy is going to be remain same. Okay, so I can directly write P1 upon rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 here. So potential energy will be cancelled out. The velocity at the origin is 0, okay, and the pressure at the origin is 10 kilopascal here, and correspondingly the pressure we have to calculate at the 3,3, density is 100, let us say gravity is 10, v square we have calculated 6 root 2 whole of square divided by 2 into 10 here. Okay, so if you just solve the entire questions here, the answer which you are going to get is equal to P2 is equal to 6.4 kilopascal here. Okay, so I can directly say the option number B is going to be the correct answer here. Okay, so you can see a large number of numerical has been already done here. Okay, out of these 6 questions I have done 5 numerical questions here, only 1 theoretical question is there. So you have to make ensure that whenever you are preparing for this particular exam, you have to focus primarily on the numericals here. Okay, and the numericals are very good, are of very good level here. Okay, so practice all the numericals here related to the every PSU exams here, or related to the GATE exams here, as well as the related to the ESC exams here. Next question. A spherical water drop of diameter 2 mm splits into 8 small drops of equal size in air at a temperature of 25 degrees Celsius. The surface tension coefficient of water in air is given to you as 0.073 Newton per meter, and the corresponding dynamic viscosity is 0.01 poise here. What will be the approximate work done in splitting up the drop here? Here in this case we have a droplet here, and it is splitting into 8 smaller droplets here like this one. Okay, and correspondingly the diameter of this particular large drop is given to you as it is equal to 2 mm, and the corresponding diameter of the small droplets are not known to us. Okay, so first of all we have to calculate the values of the radius, or I can say diameter of the small droplets. So here in this case the volume of the droplet the volume of the droplet is going to be equal to volume of smaller droplet here. Okay, so here you can see the volume of the droplet will be 4 by 3 pi r cube, and there are total 8 number of droplets here. Okay, and correspondingly we don't know the value of radius, so it will be r cube here. So here in this case, if you just solve the value of the radius here, the values of the radius are going to be equal to 5 into 10 to the power minus 4 meter. That will be the value of the radius of the small droplets which are getting produced here. Now correspondingly, what do you want to calculate? You want to calculate the value of the approximate work done. So I can directly write, okay, so now just see, in this case we have to use this particular formula. The surface tension is equal to the work required to bring the change in area here. Okay, so basically is equal, it is going to be equal to sigma is equal to delta W by delta A. Okay, and in this case sigma is given to you 0.073, work we have to calculate, delta A will be the final area minus initial area. Okay, so now finally we have 8 droplets. Here we have 8 droplets with area of 4 pi r square. Okay, and correspondingly initially we have a larger bigger size droplet here which is having an area of 4 pi r square. Okay, so if you just solve this, you are going to get your final answer. Oh sorry, just wait a minute, 4 pi, just give me a second here. We have a diameter is 2 millimeter now. So first of all, here we have to put, here we have to put here 0.01, because diameter is given to us, it is not radius. 2 millimeter is not the radius, it is the diameter here. And correspondingly in this case also, here we have to put 0.01 here, 0.001 here. Okay, and correspondingly the delta W is coming out to be around 0.92 into 10 to the power minus 6 joule here. Okay, so that will be the final answer in this case. So I can directly say the option number B is going to be the correct answer here. Okay, so again the question is very simple, although the calculation is required here. Next, which is identified as the coefficient of the momentum transport here? So that's a very simple question actually. The kinematic viscosity is a parameter which tells you about the momentum diffusion rate across the fluid layer, whereas the thermal diffusivity is a parameter which tells you about the thermal diffusion rate which is passing through the fluid layers here. Okay, whereas the Reynolds number is a dimensionless number which tells you about the comparison of inertia forces to the viscous forces, and it is used to classify the flow as laminar or turbulent flow here. Whereas the density represents you the how the heaviness, what is the heaviness of the fluid here. Correspondingly, the dynamic viscosity is representing you the internal fluid frictions here. Okay, so option number B will be the correct answer in this case. Next, which is the most economical depth of the flow in an open rectangular channel here? Okay, so this question is related to the open channel flow, although the open channel flow is not so much important for the mechanical engineering, so you can skip that part here. Okay, and in this case basically the question option number C is going to be the correct answer, that the depth of flow is going to be equal to half of the width of the channel. So that is basically theoretical question here. Okay, either you can just remember that condition here, or either you can solve the entire derivations here. Okay, that's a very simple case. Next, a planar 4-bar mechanism is with all the revolute joints with the link length AB equal to 30 millimeter, BC equal to 120 millimeter, CD equal to 100 millimeter, and AD equal to 80 millimeter. So here we have a 4-bar mechanism. In this case, AB, CD. So here we have mechanism, this one, AB is given to us 30, BC is given to us 120, CD is 100, AD is 80. The link to be fixed to obtain a double crank mechanism. Okay, so just see, first of all in this case again we have to check the Grashof flow conditions here. And what is a Grashof flow? Again it is basically a S plus L, it has to be less than equal to P plus Q here. So according to the diagram, S is going to be equal to 30, L is going to be equal to 120, P is going to be equal to 80, Q is going to be equal to 100. Okay, so you can directly see S plus L is 150 here, and P plus Q is equal to 180 here. So I can say the Grashof law has been satisfied here. Grashof law has been satisfied here in this case. Okay, so Grashof law has been satisfied here in this case. Now, in order to obtain the different inversions, we are going to fix the different links. So first of all, let us suppose if you just fix the smallest link, you are going to have a double crank mechanism. Okay, if S is adjacent to the fixed, here, in that case we are going to have a crank rocker mechanism, and if S is opposite to the fixed, here, we are going to have a double rocker mechanism. Okay, so now you can see, in order to obtain the double crank mechanism, we have to fix the smallest link. So I can say the AB link has to be fixed here in order to obtain the double crank mechanism. So option number A has to be the correct answer in this case here. Okay, now the next part. Okay, so the next question is, a flat belt run over a pulley and transmitting the power of 2.5 kilowatt. The linear velocity of the belt is 2.5 meter per second. Let me write the conditions for you. So in this case, the power is given to us, that is 2.5 kilowatt, and correspondingly the velocity of the belt is given to us 2.5 meter per second, and the angle of lap is given to us 165 degree here. Okay, now in this case the coefficient of friction between the belt and the pulley is 0.3, and if the initial tension of the belt is increased by 10%, so let us say Ti2 is representing the initial tension. Okay, after increasing, it is equal to 10% of the initial tension in the first case. So initially we have some initial tension, then we have increased it by the 10% here. Now what will be the effect on the power transmission here in this case? We have to neglect the slip and centrifugal effect of the belt here. So how to solve this problem here? So first of all, in this case, just see, power is given to us and the power is equal to T1 minus T2 into velocity. That is the formula here. So in this case, 2.5 into 10 to the power 3 is going to be equal to T1 minus T2 multiplied by velocity here. Okay, so from here you are going to find the relationship between the tight side tension and the slack side tension, which will come out to be as 1000 Newton here. And correspondingly we know that the ratio of these two tension, that is T1 by T2, is equal to E mu theta here. Okay, so I can write T1 by T2 is equal to E 0.3 multiplied by pi 180 multiplied by 165 degree here. Okay, so you are going to get the relationship of the T1 by T2 as, let me write it here, T1 by T2 as 2.372. You are going to get this particular relation here. So if I use this relation in this first equation, T1 minus T2 equal to 100, so 1000, you are going to obtain the value of the T2 here, and it is coming out to be around 728. I have calculated it with my calculator. With my calculator, it is coming out to be like this one here. Okay, so just calculate it one more time and just get the accurate values here. Okay, and correspondingly I can write the value of the T1 is going to be equal to 1728.862. Okay, so these are the initially the tension on the tight side and the tension on the slack side here. So now here comes the part, what is the initial tension here? So it will be simply the arithmetic mean of these two here. So the answer is going to be equal to 1728.862 plus 728.862 divided by 2 here. So I can write the initial tension is going to be equal to, it is coming out to be around, just give me a second here, 122.8.862. This is the value of the initial tension. Now the initial tension has been increased by 10%. Now it has been increased by 10% here. Okay, so if you just calculate the increased initial tension, it is coming out to be as 1351.7482. This is coming out to be like this one here. And correspondingly, now again if you calculate the values of the right side tension and the tight side tension based on this new initial tension, the relation will come out to be as the relation is coming out to be around 2703.4964. You are going to get this particular value here. Okay, so now again see, we are not changing the values of the coefficient of friction, we are not changing the values of the angle of flap here. So I can say mu and theta are not changing here, mu and theta are not changing. Therefore I can write T1 by T2 is going to be equal to 2.372, the previous case. Okay, and if I use this condition in this particular equation, you are going to obtain the value of the T2. It is coming out to be around 801.748, and correspondingly the new T1 tension on the tight side will become 1901.748. Okay, so I can say the new power T2 is going to be equal to T1 minus T2 multiplied by velocity here. So I can write the final power is going to be equal to 2750 watt here. Okay, or I can write 2.75 kilowatt here. So therefore if you just calculate the value of the percentage increase in the power, you are going to obtain P2 minus P1 by P1 multiply by 100 is going to be equal to 2.75 minus 2.5 100. It will come out to be around 10% here. Okay, oh sorry, it will come out to be around 10% here. So that simply means the power has been increased by the factor of 10% here. Okay, so I can say in this case the power transmission is going to be increased by the 10% here in this case. So let us suppose if you are increasing the initial tension of the belt by 8% or 15%, the corresponding same amount of power increment will be you are going to get observed here. Okay, so you don't have to do this entire calculation if you know this, if you have done it 1 or 2 times. Next question, vapor pressure in millimeter of mercury of a solid and the liquid ammonia is given here. ln P equal to something is given and ln P is given to something here. Find out the triple point. So basically the triple point is a point where all the solid, liquid and vapor phase coexist to each other, and the values of the pressure and temperature are going to be fixed here. So I can say the vapor pressure at the triple point in the solid phase and the liquid phase are going to be remain same. So therefore I can say 23 minus 23.1 minus 3749 upon temperature is going to be equal to 19.6 minus 3049 upon temperature here. And if you solve this entire question, you are going to get the value of the temperature as 200 Kelvin. So just equate it and find out the value of the temperature. That's a very simple case. So option number C will be the correct one here. Okay. Next question, what is the change in entropy when the water is vaporized at 100 degrees Celsius? Latent heat of vaporization of water may be taken as 2238. So again that's a very simple question, because in this case we have a water at point number 1 and we are simply vaporizing it to the saturated vapor at a constant temperature. So in that case the entropy change is taking place. The entropy change you can simply calculate by the ratio of latent heat by constant temperature, HFG by T here. So now in this case I can write HFG is given to us 2238. Temperature is given to us 100 plus 273. Okay, so if you solve it, you are going to get the answer as 6 kilojoule per kg Kelvin here. You don't have to do the calculations here. Just by the observation you can answer this question here. Okay. Next question. Examine the following statement. Work is a high grade energy. Yeah, that is a correct one here. Okay. It is possible for a heat engine to produce work in a cycle by exchanging heat with the bodies at the same temperature here. So this is basically a wrong statement, because according to the Kelvin Planck statement, in order to produce a work from in a cycle from an engine which is operating between the two different reservoirs, they has to be maintained at two different temperatures here. Okay, they have not to be maintained at the same temperature. The required condition is that temperature difference should be there in order to make the heat flow. Okay, so statement number 2 is wrong here. Next, it is impossible to construct a device which operating in a cycle will produce no other effect other than the transfer of heat from a cooler to a hotter body. That is a correct statement here. Okay, that is a closest statement here. So in this case, option number C will be the correct one. Statement 1 and 3 are the correct here. Next part, a Mohr diagram is also called as, that is a simple case enthalpy entropy diagram is a Mohr diagram here. Next, a real gas behavior approaches the ideal gas equation. So generally just see, real gas normally follows the van der Waals equations here or some experimental equations here. Okay, but the ideal gas equation is written as PV equal to MRT. So in order to make ensure that you can use the ideal gas equation for the real gas, you have to make ensure the pressure has to be very low and the corresponding temperature has to be very high here. So I can say the real gas approaches the behavior of the ideal gas when the pressure is very low and correspondingly the temperature is going to be very high. So that is the required condition here. So option number D will be the correct answer. Okay. Next question. The equation of motion of a spring mass damper system is given by this one here. What is the damping factor of the system here? Now what is the meaning of damping factor? First of all, damping factor is defined as zeta. It is basically a ratio of the damping coefficient to the critical damping coefficient here. Okay, just remember that value, that is very important for you. And in the case of a damped system, the governing differential equation is written as x double dot plus 2 zeta omega n x dot plus omega n square x equal to f naught sine of omega t. Okay, so if you just compare these two equations, you are going to see that 2 zeta omega n is going to be equal to 4 here. Okay, and correspondingly omega n square is going to be equal to 16. So I can write omega n will be 4, and here I can write the zeta will come out to be here 0.5 here. Okay, so option number B will be the correct answer here in this case. Okay, so again that's a very simple question. Next question. A gear train comprises 4 spur gear. The driven gear G1 is there. 2 idlers are given G2 and G3, and the driving gear is mentioned as G4 here. Okay, so let us suppose we have a gear train like this one here. So this is G1, this is G2, this is G3 and G4. So I can say each shaft is consisting of only one gear, so that means this is a simple gear train here. Okay, along with that G4 is the driving gear, it is the driving gear here, and this is the driven gear here in this case. Okay, this is the driven gear. Now what do you want to find out? You want to calculate the values of the ratios of the angular velocity G1 to G4 here. You want to calculate the value of omega 1 by omega 4, which is equal to n1 by n4 here. Okay, so just remember that in the case of a simple gear train, when you define the speed ratio or velocity ratio, it depends only upon the number of teeth of the final gear, driving gear and the driven gear. It does not depend upon the idler gears here. Okay, the idler gear are there only to change the direction of the motion here. Okay, so here I can say n1 by n4. So there are some relation here. First of all, you have to remember D is directly proportional to T here, D is inversely proportional to the N here. Okay, and correspondingly N is inversely proportional to the T here. So I can directly write N1 by N4 is basically equal to T4 by T1 here, which can be written as D4 by D1 here. Okay, so now you can see the ratio N1 by N4 will become equal to D4, that is 2 of R, radius of the gear number 4 and the radius of the gear number 1, that is R. So I can say N1 by N4 is going to be equal to 2 here. So option number C will be the correct one here, because no other option is matching here. Okay, so you don't have to find out the exact directions here. So always remember that when the number of idler gears, are odd, in that case the direction are going to be remain same. Direction will be same here. But if the idler numbers are even, in that case opposite direction you are going to observe here. Okay, just remember that part. Here you can see if the gear number 4 is rotating in the clockwise direction, gear number 3 has to rotate in the anti-clockwise direction here, and correspondingly the gear number 2 will rotate in the clockwise direction, and similarly gear number 1 will rotate in the anti-clockwise direction here. So directions are going to be opposite if the even number of idler gears are there. Okay, just remember that part here. So option number C will be the correct one. Next question, the uniform link shown in the following figure has a mass of 12 kg. If the spring is unstretched at theta equal to 0, determine the angle theta for the stable equilibrium. Neglect the surface friction and the assuming gravity is equal to 10 meter per second here. Okay, so first of all just understand in this case, let me just create a free body diagram first. So here we have a spring, and initially the body is something like that here. Okay, so now what you are doing, you are just displacing the system, you are just disturbing the system here, due to which what will happen, the spring will get stretched by some distance here like this one, and the link will become here. So now I am assuming the link has been, the entire system now comes under the stable equilibrium case here. Okay, so in this case this is representing the theta, here, and the length is L here. Okay, so now you can see when the value of theta is equal to 0, the spring is not stretched. Okay, just wait a minute here. So now you can see when the link has been rotated by theta degree, the correspondingly the spring has elongated by this much distance here. This much elongation is there of this spring here. Okay, so can I say that if this is L, A, B, let us say C, and this is D. So now you can see delta is going to be equal to CD minus AC here, and CD is equal to length, CD is equal to L here, where AC is equal to L cos of theta here, So I can say that spring has been elongated by the length of L 1 minus cos of theta first. Okay, so now just see, under the stable equilibrium, the torque due to weight and the torque due to spring force has to be balance each other here. So in this case, if I just calculate the value of the first of all spring force will become K into delta, that will be K L 1 minus cos of theta, and correspondingly the torque due to spring is going to be equal to K L cos of theta multiply by this distance L sin of theta, BC. Why BC? Because now I am considering that at the stable equilibrium, the moment the torque due to the spring force and the torque due to the weight of the link has to be balanced here about point number B. So this particular distance BC is going to be equal to L sin of theta here, and if you just solve it, you are going to get the final expression as K L square 1 minus cos of theta multiply by sin of theta. And the second thing is torque due to weight. So now in this case you can see the weight is acting here, mg, okay, and it is acting through the distance of this one here, this distance here, okay. So I can directly write, I can just directly write tau w is going to be equal to mg multiply by this b, this distance here, that will be L by 2 sine of theta here, okay. So now for the stable equilibrium I can write, oh sorry, yeah, L sine of L by 2 sine of theta. So now for the stable equilibrium, these two opposite torque has to be equal here. Under that condition, only the spring can remain stable. Tau s has to be equal to tau w. So tau s is going to be equal to k L square 1 minus cos of theta multiply by sine of theta is going to be equal to mg L by 2 sine of theta here. Okay, so here you can see L will be cancel out here, sine of theta will be cancel out here. So I can write 1 minus cos of theta is going to be equal to mg upon 2kl, and cos of theta will become equal to 1 minus mg upon 2kl. Okay, so that will be the required condition. Now put all the values here. Mass is 12 kg, K is 200, L is 0.6 here. Mass is 12 kg, gravity is 10, stiffness is 200 or L is 0.6 here. Okay, so if you just solve this entire expression, you are going to get the value as theta equal to 60 degree. So I can write option number B will be the correct answer here. So again, that's a very simple question, although you need to do some calculations here. Next question. For water, the latent heat of freezing is 334 kilojoule per kg here, and the specific heat capacity averages 4.19 kilojoule per kg here. The quantity of the heat to be removed from 1 kg of water at 30 degrees Celsius in order to turn into ice at 0 degrees Celsius will be. Okay, so we have a water and we have to convert this water into the ice at 0 degrees Celsius. So what we have to do, initially the water is maintained at a temperature of 30 degrees Celsius. Okay, so I can write, first of all we have to convert 30 degrees Celsius liquid into the 0 degrees Celsius liquid, and then we have to convert it into this 0 degrees Celsius solid here. So initially we have to absorb the sensible heat and then we have to absorb the latent heat here. So I can write mass of water into specific heat into temperature difference plus latent heat, that is mass of water multiplied by HFG. So that much amount of heat has to be absorbed here. Okay, so now you can see mass is 1 kg, Cp is given to you as 4.19, temperature difference is 30 minus 0, HFG is given to you as 334 here. So in this case the Q is going to be coming out to be as how much value you are getting here, 459 kilojoule here. That much amount of heat you have to reject from the system here. So option number A will be the D will be the correct one here. Next question. A cam and an oscillating follower mechanism is shown in the figure below. What will be the mobility of the mechanism? Mobility simply means degree of freedom here. Okay, and we know the degree of freedom is having a formula of 3L minus 1 minus 2J minus H minus F of R. So now calculate the number of links. So here we have first link, fixed link here. We have a cam, link number 2. We have this rod, link number 3, and this roller, link number 4. Okay, 4 links are there. Number of joints here. So here we have first joint, here we have second joint, here we have third joint. So number of joints are 3. How many higher pair are there? There is only one higher pair at this particular location. Okay, and correspondingly we have a redundant motion of the roller here, because it can simply rotate, which is not producing any effect in the mechanism. So I can say the redundant motion is 1 here. So if you just solve this entire equation, you are going to get the degree of freedom is coming out to be equal to 1 here. So option number C will be the correct one answer here in this case. Okay. Next question, which of the following represent the Stirling cycle? So basically there are two cycles, Stirling cycle and the Ericsson cycle. Stirling cycle and the Ericsson cycles are those cycles in which there are two constant volume processes as two constant pressure processes, and the two isothermal processes are here. Okay. In the case of a Stirling cycle, we have 4 processes, 2 constant volume and 2 isothermal processes are there. In the case of Ericsson cycle, you are having the 2 constant pressure, 2 isothermal processes are there. So you can see in this case graph number 1 is the correct one, because here we have 2 constant volume processes. Okay, so this one is incorrect here. So now in this case again 2 constant volume processes are there, but 2 isentropic processes are there. So that means it is not a case of Stirling cycle, it is a Otto cycle here. Whereas if you just see this diagram, in this case we have a 2 constant volume process, along with that you have a 2 isothermal processes. So I can write the graph number 1 and the graph number 4 is going to be the correct answer of this case here. Okay, although it is not mentioned that there is a constant volume process, but you can assume it here. Next question, rapid and the sharp change in the fluid properties in a very small region of the gas flow is known as the. Okay, so that's a simple definition of a shock wave. Okay, there is nothing to explain here. Shock wave is basically representing you the rapid and the sharp changes or the generation of the waves which can disturb the entire systems here. Okay, so that is the definition of shock wave here. Here in this case, the wall of a chemical plant is modified with 2 additional layers having the half of the thermal conductivity of the original wall material. Okay, so let us suppose if you have a wall, this is a wall of chemical plant which is having a thermal conductivity K and which is having a thickness of L here. Okay, now what we have done, we have just modified this wall here. So let us say here we have another wall, the same wall is there. Okay, the same wall is there, but with some modifications. What type of modification you have done? The inner layer is of half the thickness and the outer layer of the same thickness as the original wall. So here you have installed the thickness here, inner layer. This is the inner layer. Inner layer is having the thickness of L by 2. Okay, and correspondingly outer layer is having a thickness of L here, and you can see additional layers are having the thermal conductivity half of the wall here. So I can say it is having a thermal conductivity of K by 2, it is having a thermal conductivity of K by 2. Okay, and the center one we have a K. Now what will be the heat flow across the modified wall? So first of all, just calculate the value of the heat flow here in this case. It will be equal to Ka delta T by L here. In this way you can calculate the heat flow in the first wall. Okay, now in the second case you can see Q is going to be equal to, Q2 is going to be equal to delta T. I am assuming the same temperature difference has been maintained across the wall here. So now L by 2 K by 2 multiply by area plus L by Ka plus L K by 2 multiply by area here. Okay, so if you just simplify it further, you are going to observe Q2 is going to be equal to delta T by L by Ka plus L by Ka plus 2L by Ka. So I can write delta T 4L by Ka. You are going to get this expression here. So let us suppose, you can see here Q2 is going to be equal to Q1 upon 4 here. That simply means now the modified heat is basically equal to the 25% of the initial heat flow. Okay, so here in this case the option number D is going to be the correct answer. The heat flow is going to be equal to the 25% of the original one here. Next question. Three metal balls are suspended by the three wires A, B and C of equal length, arranged in the sequence as shown in the figure. The mass of the ball starting from the top are 2 kg, 4 kg, 3 kg. The wire diameters are given to you as 2 millimeter, 1.2 millimeter and 1 millimeter respectively. What is the correct order of the increasing stresses here? Okay, so now just see the diagram very carefully. First of all, just calculate the stresses induced in the wire number 1 due to this weight here. So can I say that wire number 1 is holding all of these weights are acting at the bottom of the wire number 1. So I can say the total load which is acting over the wire number 1 is equal to the summation of this one here. I am assuming gravity as a 10 here, okay, for the sake of simple calculations here. So mass into gravity, weight is considered, and the area is pi by 4, 2 millimeter. Okay, so here you can calculate the sigma 1 is coming out to be around 28.104 into 10 to the power 6 here. So now you can calculate the value of sigma 2. So in the wire number 2 only these two weights are acting at the bottom here. So I can say 4 plus 3 multiply by 10. Okay, just do one thing, just assume the gravity as 9.81 only, because the answer which I am providing you is based on the actual value of the gravities here. Wire number 2 is having a diameter of 0.0012 square, and the corresponding stresses you are going to observe 60.718 into 10 to the power 6 here, and correspondingly the sigma 3 is going to be equal to 3 into 9.81 divided by pi by 4, 0.001 square. Okay, and the answer will come out to be as 37.471. Okay, so in that case you can see the correct order of the increasing stresses are A, the first wire, then third wire, and then this second wire. A, C and B. So option number A will be the correct answer here in this case. Okay, so again the question is very simple and the direct formula based question is here. Next, what is the power of 2 ton of refrigeration system? Latent heat of ice is given as 336 kilojoule per kg, specific heat is given as 4 kilojoule per kg Kelvin. Okay, now it is being asking you to what is the power of 2 ton of refrigeration system here. So first of all, how do you define the 1 ton of refrigeration? The amount of the 1 ton of refrigeration is defined as the amount of heat required to remove from the 1 ton of a water, okay, which is maintained at a temperature of 0 degrees Celsius, in order to convert it into the ice in 24 hours here. Okay, so I can say 1 ton of refrigeration is equal to amount of heat to be absorbed from the water at 0 degrees Celsius in order to convert it into the ice at 0 degrees Celsius in 24 hours. That is the definition here. Now how do you calculate it here? In this case I can write 1 ton of refrigeration. So first of all, 1 ton is equal to 1000 kg, and the amount of heat which has to be absorbed is 336, and we have been provided 24 hours here. Okay, this is the definition of the 1 ton of refrigeration. So if you solve it, you are going to get the value as 3.889 kilowatt here. So now in this question, it is asking you about the power for the 2 ton of refrigeration. So 2 ton of refrigeration simply means 2 into 3.3889, and the answer will come out to be around 7.778 kilowatt here. Okay, so I can say the option number A will be the correct one here in this case. Okay, so again the question is very simple. Next question. Air standard Otto cycle operates with a compression ratio of 9. Ambient temperature is 300 Kelvin and the adiabatic index of the medium is 1.5 here. What will be the efficiency here? So that's a direct formula based question. In the case of an Otto cycle, we know efficiency formula is this one. Just put the value of the compression ratio, that is 9, adiabatic index as 1.5 minus 1, okay, and the efficiency will come out to be as 66.667% here. So option number B will be the correct one here. Next, a Carnot refrigerator work in a temperature range of 300 Kelvin to 270 Kelvin with different refrigerant CFC, R32 and ammonia here. Okay, which of the refrigerant give the better COP? See, here the Carnot refrigerator is operating and the Carnot refrigerator is having a COP of simply T lower by TH minus TL here. Okay, and its COP depends only upon the temperature limits. It does not depend upon the type of the refrigerant fluid here. So I can say all of the refrigerants are going to give us same COP here. Okay, if they are working on the same temperature limits. Next question. A cylindrical body of diameter 2 meter and height 1.5 meter having a mass of 2 tons and float in a sea water with its axis vertical. So here we have a body which is having a mass of 2 ton, okay, and it is having a diameter of 2 meter and a length of 1.5 meter. A lighting equipment is placed on a body such that the water level is at least 0.5 meter below its free surface. So here what we have done, we have just placed an equipment over this body, and due to this body, the entire structure has been submerged in the liquid in such a way that the top surface is lying 0.5 meter above the free surface here. Now the question is, what is the maximum mass of the electrical equipment that can be placed on the body here? Okay, so now just see in this case, simple, this is a case of a floating body here, so I can use the principle of flotation here. Okay, so according to the principle of flotation, Fb is going to be equal to W, and now we know the buoyant force is equal to the weight of the liquid displaced by the body here. So I can write the density of the water multiplied by gravity multiplied by the submerged volume. It has to be balanced by the overall weight of the structure here, which will be equal to mass of the ship plus mass of the electrical equipment here. So this will be the final equation which you have to calculate here. Now just put all the values here. Density of the water is 1000, gravity is given to you 10, submerged volume you can simply calculate pi by 4, d square, height is 1 meter, and mass of the ship is 2000 kg, mass of electrical equipment we have to calculate, okay, and the gravity is given to us as 10 here, let us suppose. So if you solve this entire equation, you are going to get the value of Me as it is coming out to be around 1204.4 kg here. Okay, so this will be the final answer here. So I can say the option number C will be the correct answer here. Now the next question. Examine the following statement. Euler equation is applicable to the inviscid law. They see, first equation is the correct one here. Why? Because whenever you are covering the fluid mechanics, there are different type of equation of motion. Like we deals with the Euler equation, Bernoulli equation, Reynolds equation, as well as the Navier-Stokes equation of motion here. So in the case of a Euler equation, you are considering only the pressure forces and gravity forces. You are not considering the viscous forces here. Okay. So I can say the statement number 1 is correct one here. Second, Bernoulli equation is applicable to the steady state. That is correct here. That is the assumption which we normally take. The flow should be incompressible. The flow has to be steady state. Okay, like this one here. Viscous forces are not considered in the Navier-Stokes equation. That is a wrong statement. Okay. Next, surface tension and the compressibility forces are considered in the Navier-Stokes equation? That is wrong, because in the Navier-Stokes equation we are considering gravity, pressure as well as the viscous forces here. So statement number fourth is also wrong. Okay, so if you match the options here, none of the options are correct here. Okay, although the option number C was given as a correct answer, but you can raise it as an objection here. Okay, so this is the paper analysis of the ISRO here. So you can see in the entire paper there are a lot of numericals here, okay, and a very less number of theoretical questions are there. So you have to make ensure that whenever you are preparing for this particular exam, you have to prepare for the numericals also. Okay, and the numericals you have seen, the very lengthy, some numericals are very lengthy. In that case you have to just improve your calculating speed also. Okay, so that is for this particular today video. So thank you very much.